लाइव तो चल रहा है।
हेलो
ठीक हो?
सही आ रही है। यहाँ से लीव कर देते हैं। थोड़ा दिक्कत हो रही है मुझसे लैपटॉप में कुछ गचर बचर ना हो जाए। ओहो मेरा मास्क कहाँ है? अच्छा So, good morning, everyone. Myself, Dr. Usha Tiwari. So, on the behalf of Department of Electrical, Electronics and Communication Engineering, I welcome you all on the day 2 of our FDP on wireless sensor network and IoT applications. So today we are having with us our eminent speaker, Professor Dr. R.M. Mehra. So he's basically the Professor Emeritus, Department of Electrical Electronics and Communication Engineering, School of Engineering and Technology, Sharda University. So before basically starting his lecture, I will like to give the brief introduction of Professor Mehra. So Professor R.M. Mehra holds PhD degree in physics from University of Delhi, and he superannuated from University of Delhi in January 2010 and joined as a professor emeritus at Sharda University. So at University of Delhi, he was engaged in teaching, research and administration, and he has been a postdoc research fellow of Japan Society of Promotion of Sciences. So he also being an HOD of Department of EC, Dean Research, and presently he is advisor, Learning Resource Center, Sharda University. So he has already supervised 42 PhD research scholar for award of doctorate degree. So he has executed more than 17 research projects sponsored by the national associations like DRDO, UGC, DST, CSIR, MNRE, IUAC, and international associations like NSF, USA, and JSPS, Japan agency. He has widely traveled abroad for research, teaching, and consultancy assignments to university in USA, Japan, and Europe, and he is member of several academic and professional bodies and has chaired Semiconductor Society India. So Professor Mehra has published more than 250 research papers in reputed international and national journals and conferences, and his mainly research area is in semiconductor material devices and wireless communication. So today, Professor Mehra, he will basically cover the wireless communication. And over to you, sir. Professor Mehra.
Thank you very much. How many have joined so far?
Sir, 39, 40 participants are there, sir, around.
So I think few more will be joining soon.
Yeah. We can wait for 5 minutes. Yeah.
Wait for 5 minutes.
Yeah.
Okay.
So all the participants, if you have any kind of a query and questions that you want to ask with Professor Mehra, you can basically type on a chat box also, and you can unmute yourself and then you can ask a question in between also. And when there is no query, please mute yourself. So now 48 participants are there. So by the time you can share your screen.
Just a minute. Just a minute.
Yeah.
Just a minute. I hope it is visible.
Yes, sir, it's visible.
Okay.
Some noise from the participant. Please mute yourself.
Good morning, sir.
Good morning. '78.
Yeah, I think, sir, we can start.
Okay.
Mera sir, we can start. Yeah.
Okay. Okay. Yeah. So thank you all, my colleague from Department of Electrical and Electronic Communication Engineering, and our students uh, from our department. There are many number of students who have joined for this lecture. And yesterday I have spoken on the value-added courses, and I hope that my message has gone well with the student and the faculty members, that value-added courses, uh, although they are part of our curriculum, but then value-added courses gives you opportunity to do beyond your subject area from or in different subjects. So today I'll be speaking on wireless sensor network, Internet of Things, and its application. There are two presentations, one on WSN with part one and part two, and then the other is on IoT. And you will see that how important is this combination of these two subjects, WSN and IoT. Both are not new, but the combination is new. The applications are new. And serving the society, human being, all kinds of needs, all kinds of monitoring, controlling can be done with the help of WSN plus IoT. Uh, the the presentation on IoT, I have kept it original from University of Surrey, and you will find that that will give you an idea to the students as well as to the faculty members that what actually we mean by IoT, a center for, say, IoT applications, and what are the hardware, software requirement, and what it can do. So we can have an idea, and there are several links are also there in that presentation, and one can, students and faculty members can click on those links and can get more and more and more information. So, uh, so wireless sensor networks, that means the three words are there. One is wireless communication. We all understand. I have taught this subject at UG and PG level of our students. And then sensor, but here the thing is there are sensors, that is the second part, and then combining sensors with certain networks, So these three things together makes wireless sensor network. So if we, as I said, that in this particular lecture, there are two parts. So one will give you little more information on hardware and modes and wireless sensor network. Modes are uh, the key component of WSN, and then WSN application. and Tiny OS and WSN research at the Dialog Lab. So modes and wireless sensor networks. So if we see what actually we mean by mode, Dr. Rashmi and her research group has worked a lot on this particular subject, and she has also completed her PhD and published several research papers. I think Rashmi should share all those research papers with the students who are attending this, so that they know what is exactly going on. And one more student and another faculty, Ruchi Yadav, she is also continuing research work in the same area. So whatever research work is done, actually it is not only for this area of WSN. Whatever research work is done by faculty member of our department, Electronics and Communication Engineering department, uh, that should be shared on regular basis with the students. So that will make, the students also, they will be motivated and create, those look, we are our faculty members, our teachers are doing this kind of research. We can join and things like that, because the student support is the wonderful support in any research area. So it's a very low cost, low power computer, monitors one or more sensors, a radio link to outside world are, are the building blocks of wireless sensor network. And what it contains, a radio transceiver, external memory, microcontroller, D2A to D converters, analog input output ports, digital input output ports, and sensors. And these sensors actually, this is a different area of research actually. And of course, as far as my knowledge goes, that we are not developing sensors. We use sensors which are already available commercially. So if we look at, there are many definitions, but people are very used to click Wikipedia to know what a particular subject is. So as per Wikipedia, it says a wireless sensor network is a wireless network consisting of, the important point here is spatially distributed. Spatially distributed. Let me see if I can highlight this. This permits me. Then uh, okay, I give a different color to this, right? And I save. I do this because just to keep interest going on. So wireless sensor network is a wireless network consisting of spatially distributed. So here, everywhere, autonomous devices using sensors to corporately monitor physical or environmental conditions such as temperature, sound, vibration, pressure, motion, or pollutant at different locations. Look at the application. We all are surrounded by these things. We we are accustomed to variation in temperatures, sound. We are accustomed to vibrations, pressures, motion, or pollutants, which is more important. Pollutant is also more important in different locations. So, formed by hundreds or thousands of modes that communicate with each other and pass data along from one to another. So that is the role of these modes, and they are especially distributed. And among these nodes, there is a super node and then links to other network and similar super nodes. So this will be, in military application, in agriculture application, the number may go even 10,000 and even more. So very, very tiny. They are very, very tiny sensors, This is very small device. So it can be, I mean, just like a powder powder, you can drink, sprinkle and this, it is distributed all over. And then it is working. The point is that it is working, it is sending data. Research done in this area focus mostly on energy aware computing and distributing computing. Energy is always a factor, that how much energy each sensor will, because if there are millions, if there are lakhs or thousands of sensors, all need some electrical energy to get to be operated. So if the energy requirement, that has also to be considered. So various applications: environmental habitat monitoring, acoustic detection, seismic detection, military surveillance, inventory tracking, medical monitoring, smart spaces, process monitoring. Look, the no area is left where WSN has not has no application. So, and these things are in use actually. Now, it is not a theoretical. It is not in theory and just in air, but it is all being done. So this. So as I said, that my presentations, I've kept few things very original. My presentation will give you certain links if you, and I hope you are interested in this topic. It's one of the value added course. So you must click these links. So this is Intel Research Laboratory at Berkeley, initiated a collaboration College of Atlantic in Barnes and University of California at Berkeley to deploy wireless sensor network on Great Duck Island. So there is an island, there so many ducks are there, and we have to monitor and control and see the health and other things of the so they two big institutes, they joined together to do this kind of work. Monitor the microclimates in and around nesting burrow used by leech storm petrel. So no other device, no other combination can do this kind of a work. Physically, you can't do anything like that. But with the help of WSL, it has been made possible. Goal: Habitat Monitoring Kit for researchers worldwide. So Firebug, wildfire instrumentation system using network. You hear every day that in Australia, in USA, there is a fire in jungles, you know. So what to do? You can't go there. So wildfire instrumentation system using network sensor allows predictive analysis of evolving fire behavior. So if you know something about this fire behavior, and you can then make certain measures and locations. So you have seen these things many times on TV news channel, that how this fire is under control with the help of some sprinkling water or some other material liquid to seize this fire. So Firebugs GPS enabled. Look, everything is there. GPS enabled wireless thermal sensor modes based on TinyOS, that is self-organized into network for collecting time data in wildfire environment. So, I mean, you just imagine, you know, you are sitting at home and you're controlling everything. Software architecture, several interacting layers, sensors, processing of center data, command center. And a project of University of California, Berkeley, US. So big institute, research labs, they have taken this challenge and they are doing it so well. Another example, if you look at The BP experiment, collaboration with Intel and BP, use of sensor network to support preventive maintenance on board of an oil tanker in North Sea. Every day you find a news every month or thrice, 4 times, 5 times a year that oil tanker has leaked and so much oil has been there in the sea, and then the fishes and other they are being affected. So use of sensor network to support preventive maintenance on board. This is important. On board. Important is on board. On board on an oil tank in the North Sea. The sensor network deployment on board the ship, a system gathered data reliably sorry, and recovered from errors when they occurred. The project was recognized by InfoWorld as one of the top 100 IT projects in 2004. So it's a not a very new story. Things started in even in successfully started in 2004. Cricket mode, basically a location aware mode, includes an ultrasound transmitter and receiver. Use the combination of RF and ultrasound technology establish differential time of arrival and hence linear range estimation. Based on cricket indoor location system developed by a MIT researcher Nishanka Bodhi Yantha. Some name looks like an Indian based in US or some other part of the world. So, I mean, for cricket, there is also a moat developed. And what is Tiny operating system? Open source operating system, wireless embedded sensor network, component-based architecture, developed at UCB in collaboration with Intel Research, current stable version 1.1.15, TinyOS 2.0 T2 released on 6/11. Main ideas, low complexity, and this is the, and I'll again escape from here. I'll put emphasis on conserve power, sleep as frequently as possible. We all know that all of us, 100%, we are using our smartphones, and all smartphones are provided with this uh, sleep function. That if you are not using it, then your screen will become dark, so that the consumption of power from the battery becomes very low, and so the battery life in one charge becomes larger. So that is also built in this operating system, tiny operating system, written in NESC, next generation C compiler. So different targets: Mica, Mica 2, Mica 2 dot, Mica Z, Telos, Telsoc, then 2 PC, and Mica 2. There are details of uh, this. It's extremely popular mode, 8-bit AVR controller, FSK radio, data logger flash. So this is the Mica 2 mode. Then Mica 2 clone. Then data mule, a mobile entity present in the environment that will pick up data from the mode when in range, buffer it, and drop off the data at base station. Example, people, vehicles, livestock. Then these are the data view. Base station. So, application collecting data in a sparse sensor network, tracking movement of mobile elements, vehicles, livestock, and wild elements. Okay. Then the same WSN part 2. This covers environmental monitoring, medical application, data dissemination scheme, media access control scheme, distributed algorithm, which is very important. Generally, Zigbee is used, and then architecture of wireless sensor network, and final remarks. So a wireless sensor network, as we have seen earlier, also consists of base station and a number of wireless sensors, that is nodes. Uh, what is this? Okay. And wireless sensor node components, we have seen this picture. So characteristics, requirement, small size, large number, tetherless and low cost, constrained by energy, computation and communication. Small size implies a small battery. Low cost and energy implies low power CPU. Radio with minimum bandwidth and range. Ad hoc deployment implies on no maintenance of or battery replacement. If that is how we can replace battery quite often in such cases. So it should be maintenance free, and to increase network lifetime, no raw data is transmitted. So ad hoc wireless network, large number of self-organizing static or mobile nodes that are possible randomly deployed, nearest neighbor communication, wireless connections, links are fragile, possibly asymmetric, connectivity depends on power levels and fading, interference high for omnidirectional antennas, sensor networks and sensor actuators networks are a prominent example. Distinguished features, WSN are ad hoc network, wireless nodes that self-organize into an infrastructure-less network. But in contrast to other ad hoc networks, sensing and data processing are essential. WSNs have many more nodes and more densely deployed. Hardware must be cheap. Nodes are more prone to failures. WSN operate under very strict energy constraints. WSN nodes are typically static. The communication scheme is many to one, data collected at base station rather than peer-to-peer. Nodes are battery powered. Nobody is going to change the batteries, so each operation brings the node closer to the lifetime is crucial to save energy, sleep as much as possible, acquire data only if indispensable, use data fusion and compression, transmit and receive only if necessary. Receiving is just as costly as sending. Stability and reliability is another important two components. So WSN should be self-configured, be robust to topology changes, easy death of a node, maintain connectivity, can the base stations reach all nodes, ensure coverage, are we able to observe all phenomena of interest, and for maintenance, reprogramming is the only practical kind of maintenance. So again, I will highlight this different color. So maintenance, reprogramming is the only practical kind of maintenance. It is highly desirable to reprogram wirelessly. Data collection, centralized data collection puts extra burden on nodes close to the base station, clever routing, and can alleviate the problem. Clustering data from groups of nodes are fused before being transmitted so that fewer transmissions are needed because larger the transmissions, the larger will be the power consumption. Often getting measurements from a particular area is more important than getting data from each node. Security and authenticity should be granted. However, the CPUs on sensing nodes cannot handle fancy encryption scheme. So power supply, AAA battery power the vast majority of existing platforms. They dominate the node size. Alkaline batteries offer high energy density at cheap price. The discharge curve is far from flat, though lithium coin cells are more compact and boast a flat discharge curve. Rechargeable battery, who does the recharging? Solar cells are an option, you all know, for some applications. Fuel cells may be an alternative in the future. Energy scavenging techniques are a hot research topic, mechanical, thermodynamical, and electromagnetic. Radio commercially available chip, available band 433 and 916 megahertz, 2.4 gigahertz ISM band, and typical transmit power 0 dBm. Power control sensitivity as low as minus 110 dBm. Narrowband FSK, spread spectrum communication. It's a very important part in mobile communication, spread spectrum communication. DSSS, ZigBee, as I was mentioning. Here, uh, what we use ZigBee in most of the time. And or FHSS Bluetooth, relatively low rates, 100 kbps, and that saves power. So CPU microcontrol unit is the primary choice for node processing. Power consumption is the key metric in MCU selection. The MCU should be able to sleep whenever possible, like radio, and memory requirement depend on the application. 80 mega 128L and MSP 430 are popular choices. So this is shown here. 80 ml mega 128L and MSP 430. So this gives an idea that what is available, what we use, and then depending on the application you want to use it, you have to design your own network. Sensors, power efficiency of sensors is also crucial as well as their duty cycle, and MEMS techniques allow miniaturization. So this is another research area, quite this old research area of uh, MEMS. So sometime I think we have some software to MEMS designing in our department. Then applications, we have seen military, national security application, environment monitoring, medical applications, nearly anything you can imagine. So this is environmental, as mentioned earlier also, Great Duck Island. 150 sensing, so one sensing node may have many modes. So 150 sensing nodes deployed throughout the island relay data temperature, pressure, and humidity to central device. Data was made available on internet through a satellite link. Then this is to study the behavior of zebras. You can't do with any other kind of system. Special GPS equipped with collars were attached to zebras, and data exchange with peer-to-peer info swaps. Coming across a few zebras give access to the data. Then medical applications, tremendous applications in medical. Vital sign monitoring, accidental recognition, monitoring the elderly. And this is, I think, the area, healthcare area where Ruchi Yadav is working on. If I remember correctly. She is developing a wireless sensor network for healthcare. And in healthcare, one of the component of her research work is in monitoring the elderly people like me. Intel deployed at 130 node network to monitor the activity of residents in an elder care facility. Patient data is acquired with wearable sensing modes. And I request Ruchi that she must share exactly how she is designing, how many nodes, how many modes, and where to apply, how to apply. All these things, information should be shared and discussed with the students. Then data dissemination schemes, conventional method, direct communication with base station, sensor nodes, communicate with base station directly, energy consuming. And then this is multi-hop scheme, transmitted through some other intermediate nodes and energy consuming. So this is the clustering hierarchy. So sensor node, cluster head, and super cluster head. So all such research publication has been done by the research group leaded by Rashmi. All students should read these papers and have a in small groups. You should have discussion on this. What kind of research going on in the area of WSN in your department. So then this is the clustering hierarchy. Leech designed for sensor network where an end user wants to remotely monitor the environment where the data from the individual nodes must be sent to a central base station often located far from the sensor network. So desirable properties of protocols on these networks use hundreds or thousands of nodes, maximize system lifetime, maximize network coverage, use uniform battery operated node, and the use of distributed cluster formation and local processing to reduce global communication, along with randomized rotation of cluster heads, allow each to achieve the desired properties while being energy efficient. So this is media access control. This is scheme is also there in mobile communication. Two categories of MAC schemes for wireless network. Mobile is also a wireless network. Contention-based scheme designed for minimum delay and maximum throughput. Require transmission receivers to monitor the channel at all times. And reservation-based or schedule-based scheme detect neighboring radios before allocating collision-free channel to a link. And TDMA, natural choice for center network. And TDMA-based solution, self-organizing superframe algorithm, superframe TDMA period plus boot up period plus unused bandwidth performs well only under specific conditions. And power-aware cluster, TDMA pack, divide TDMA structure into control slot and data slot, and hard to maintain the cluster when there are mobile nodes. But in WSN, most of the cases, they are static nodes. Other solutions, sensor MAC, SMAC, nodes periodically sleep. Node sleeps during transmission period of other nodes and node not suitable for time critical application. So we have to choose things as per our requirement. So architecture, self-addressing requirement, local unique address, data centric. Example, each node has a unique number. Again, this we have to remember. Each node has a unique number, attribute-based naming architecture. Data is named for one or more attributes. Example, each node is distinguished by an attribute. GPS sensor are practical for this. Then an address-free architecture, AFA. Advantage, randomly select probabilistically unique identifier for each transaction, especially spatial locality, temporal locality. Some drawbacks, not applicable when static addressing of nodes is needed, and identifier conflict. So this is the last slide of this presentation, as far as I remember. And there are actually two questions are there for the students and faculty member. Can you think of any application where a wireless sensor network would be the best solution? We have shown many applications, medical, non-medical, agricultural, and fire and all those things. So think some typical situation where people are worried how to solve it, and how wireless sensor network would be the best solution. And then second part is, do you foresee wireless sensor networks becoming un, ubiquitous within the next 10 years or during your lifetime? So I think the answer will, we all agree that the wireless sensor will remain and remain and remain, and expansion in this area will be for the next 10 years or even during our lifetime. So this, I think, with this, this is the last slide. My email ID for students, my mobile number for students. Of course, faculty members knows it. So if the students want to interact with me, they can interact me on phone, messaging, WhatsApp, and other things, and also through email. So thank you very much. The next lecture, I'll take a break of 5 minutes, but then if there is any queries or questions, I'm here to answer, and our research group can also help me in answering typical questions from the students. Thank you.
Yeah,
Thank you, sir.
yes. I think, sir, one student, Shutanika, she is asking that can we use a WSN for climate situation detection?
Yeah, if I go back, it is temperature sensing is one use. We can, of course, if in the sense that climate, the kind of data which we are having, meteorological department, when there will be rain, wind speed, and all those things, that is done with other instruments. But if it is, and that is another way, this is another area where meteorological department is gathering data, and many research groups are doing that kind of work. That is study of glaciers melting and other things. Professor Rajesh was here, and still the lab is environmental lab is there. So specifically speaking, if the question is about environmental studies, the answer is no. But if a temperature monitoring in a room, in a building, that the answer is yes. That is when the air conditioner should operate, when it should not operate, we can use wireless sensor network. So that way, yes. But if it is environmental study, there are different ways and different instruments where we use for
Yeah,
environment.
sir. I think she's asking about the how to basically pre-detect the climate situation,
So
just like the storms.
WSN
Yeah.
does not work.
Yeah.
They,
Yeah, but Shutanika, yeah, in the area of earthquake and basically the earth movement detection,
yes,
yeah, people are using Amrita. You can go to the Amrita University people. They are basically they are having a very good projects where they are doing the yeah. Generally, we
Ma'am,
are having a yes, yes.
WSNs are also used in disaster management systems now, like search and rescue operations.
Yeah,
Yes,
we
sir.
are using.
we are,
And even in the Kerala, there is a common problem of your landslide.
yeah,
So there also people are using the WSN.
yes.
Yes, ma'am.
Okay, any other question? Sir, are you continuing with another lecture? IoT?
Yeah, I'll continue. Give me a break of 5 minutes.
Okay. So by the time, any questions, students, FDP members?
Sir, sir,
Yes,
am I audible?
yes.
So what we understand by the term scalability, you referred in one slide that
Yeah.
scalability and reliability.
Good,
So
good,
scalability.
good question. Uh, I'll give a simple example to understand this term of scalability. Today, suppose we are interested to monitor, say, agriculture application, or there was an example of, say, uh, some fire management, wildfire. So suppose I have developed a network for covering, say, 100 square meter. But then I realize after getting the data that what actually happening, it should, no, it should cover 200 square meter. It should cover 500 square meter. It should cover 10,000 square meter. So the network which I have already deployed I should be able to scale up, because the requirement of the protocols, the requirement of the energy conversion, the requirement of everything will increase. So scalability, not that we, if for 100 square meter, I have to dump that particular system totally. I have established base station and everything. So whatever I design, and scalability not only in WSN, even in say VLSI technology, when we develop some simulation modeling, we do design our work in such a manner that if things are changing, then we should be able to scale it up for for similar kind of application. And in case of WSN, I have just example which I give. If the area is increasing, then I should not dump my every system. A new system has to be created for that. So that is how what I understand. But I think Rashmi can speak maybe in a better terms. But this is what I understand by scalability of a particular system.
Thank you, sir. Understood, sir.
So as I said that I have not made any change. This is a presentation uh, by Dr. Payam Banagi, Dr. Chauhan at HO, Institute of Communication System Electronic Engineer Department, University of Surrey. And it's not very old, 2015. So, and for any value-added course, you have to develop a module. So this is in that particular mode. So they have given module code, we can put subject code and things like that. So, and I like this presentation. It is simple and very clear. The main aim of this module is to introduce I have kept everything original that, as I was saying yesterday also, that you must share when you say value added course. Of course, it has to be done for all subjects. But when we say value added course, we must also focus that what will be the value additions. A brief write up about that module should be there. So the main aim of this module is to introduce the fundamental concept of IoT and its application and architecture model. Introduction to technologies, mechanisms for sensing, actuation, processing and cyber physical data communication. A question for the student: how do you differ from sensing and actuation? A student can answer me at the end of this lecture. Discussing semantic technologies, service-oriented solutions, networking technologies. Here the WSN will join. That enables the integration of IoT data and services into the cyber world, the internet and the web. To develop practical skills that can be transferred into a real world environment. So this is a kind of instruments and computers and other things, they are available in that particular center. Apollo 11 command module had 64 kilobytes of memory, operated at 0.043 megahertz. An iPhone 5 second has a CPU running at a speed of 1.3 gigahertz and has 5.2 MB to 1 GB of memory. K11975 produced 80 million floating point operations per second flops, and 10 years later, K2 produced 1.9 G flops. An iPhone 5s product 76.8 G flops, nearly 1,000 times more, and K2 used 200 kilowatt of power. The smaller size, more powerful, more memory, more storage, and Moore's law comes everywhere. Moore's law over the history of computing, the number of transistors in a dense integrated circuit has doubled approximately every 2 years. So students do remember this law. And uh, so we have here anything, any place, anytime. So that is the key aspect of IoT. Anything, any place, anytime. So security, reliability, trust and privacy, services and application, data volume, networking and communication, societal impacts, economic values and three. And this is the reference has been given. You should download this paper, or the student should download this paper and try to read it. So in 60 seconds, you see the numbers, in 60 seconds, what is happening actually. See the numbers, I will share all these, all the three PPTs. One was yesterday and two was today with Ushaji, and then she will share with all the students and faculty members. Widely available programmable devices of the shared gadgets tools. All these things is available to us. Home daily life service the devices, business and public infrastructure, healthcare. So, uh, ECG sensors, motion sensor. And Ruchi is working on ECG sensors, uh, uh, and Rashmi has worked a lot on motion sensors. And then the internet comes in, and WSN and internet, they become close to each other. So, Internet of Things, uh, police patrolling, fuel, workshop, and this is the car. So complex and heterogeneous resources and networks. And so this is the area of computer science. This is the area of WSN altogether. So WSN network, so core network is the internet. Then the networks typically run low power devices, consist of one or more sensors and could be different type of sensors or actuators. Here word sensors, and then in within bracket it is written or actuator. So my question will remain for the student, that how do you differentiate between sensors and actuators? They can give their answer in writing and submit to the organizers. So how are the internet networks changing? Extension, more nodes, that is scalability. One student asked one scalability. So more nodes, more connection, anytime, any place, anything. This is the then machine to machine and Internet of Things. Billions of interconnected devices. This has to be colored and bold. Billions of interconnected devices. Everybody is connected. Expansion, broadband, LTE, lifetime evaluation, 5G. These are all we study in mobile, wireless mobile communication, LTE, 5G. And people are now, Airtel is providing 5G connectivity with optical fiber, free of cost. They are changing the modem. I think many of you might have done it. I have also done it at my home, but unfortunately, my laptop is old, my mobile is old technology, so it's not compatible with 5G. And but free of cost, Airtel is now changing your modem and changing your wiring, and they're giving you optical fiber connectivity. Enhancement, smart networks, data centering and content orienting network, context aware autonomous system. So this is an old slide. 2008, the number of things connected to internet exceeds the number of people on earth. 2003, 2010, 2015, by 2020 there will be 50 billion. So 2020 is over, and now number of things which are connected, they are more than, they are 50 billion. The source is also given. AT&T Civil National Computer History Museum, CNN, University of Michigan in Fraunhofer. Extended the current internet and providing connections, communication and internetworking between devices and physical objects. Again, I think the whole has to be in different ink, bold, save, extended the current internet and providing connection, communication, and inter-networking between devices and physical objects or things is growing trend that is often referred to as the Internet of Things. So this is one line definition of Internet of Things. The technologies and solutions that enable integration of real world data and services into the current information networking technologies are often described under the umbrella term of Internet of Things. You know, mind it, uh, LTE, LTE concept, the role of LTE concept is this, that whatever is existing, if you want to scale it up, there should be a system where everything can be modified without discarding anything which is available. So the the technologies and solutions that enable integration of real-world data and services into the current information network technologies are often described under the umbrella term of Internet of Things. And here again, LTE is doing this kind of service. Emerging technologies, growing IoT services and application in various areas, including the smart cities. There are a lot of noise when Honorable Prime Minister Modi first became Prime Minister of India of the smart cities. I have no knowledge how many smart cities have already been developed, but if developed, they will be using WSN and IoT together. And if you have some report, if students have some report, you can share with me. I will also be benefited. I will increase my knowledge. So smart cities, healthcare, transport, logistics, retail, safety and security, etc. Business trends and new opportunities. So intelligent system for more connected world. So uh, vehicles, retail, that is shoppers, communication, then managed, connected, secured, and then in medical, data breach. So WSN and IoT are going together, controlling the whole world, the activity of the whole world. So technology roadmap, the Internet of, say, Internet of Things, the technology reach, sources given, so 2000, 2010, and 2020. So demand for expedite logistic, RFID tags. Now students must be knowing, uh, of course, we are hearing of RF, it's an old technology, but now students must be visiting our library. More than 1 lakh of books which are there in the library, in the central library or in other schools library, they are all tagged with RFID tags, and everything has become automatic now. Then surveillance, security, healthcare, transport, food safety, document management, locating people and everyday objects, teleoperation and telepresence, ability to monitor and control distant objects. So physical world where these are some data in billions. This is in 2016. You can search on Google what is the exact in 4 years, 5 years, what has how these numbers have increased. Similarly, growth in internet connected devices by 2020. Uh, it is written world population in billions, internet connected devices in billions, and internet connected per person. Source is also given, so you can compare these things. How fast more internet connected devices than people. You can see every day around 20 quintillion 10 to the power 18 bytes of data are produced. That's the first time I read this word. That is 10 raised to power 18 is quintillion, 10 power 10 raised to power 18. So every day around 20 quintillion bytes of data are produced. This data includes textual content, unstructured, semi-structured, structured to multimedia content, images, video, and audio. All are contributing to this. All of us are contributing to this. So many download video and games and other things. The students are much used to downloading instead of books and journals and other things. They download videos. They share on their status on WhatsApp, and every day they change their status with many videos and things like that. So everyone is doing. Uh, so that's how this every day around 20 quintillion bytes of data are produced. Then variety of platforms, enterprise, social media, and sensors. This is again extra byte continuous per month. You can see this up to this is up to 2016. You can get another bar by 2020. You can search on internet. So stage one data collection, contest, metadata, ID, location, time, validation, format, range, source, verification, accuracy, consisting. So that is interaction, feedback, and control. Stage two, data analytics. Stage three, data use and reuse. The ultimate goal is transforming the raw data to insights and actionable knowledge and or creating effective representation forms for machines and also human users and creating automation. So this is actually the main aim. This usually requires data from multiple sources, near real-time analytics and visualization and or semantic representation. So this is 2020. Everything has come on IoT and WSM. Interesting slide. So cyber physical system is smart device, sensors and actuators, key application, protocols and architecture, network and communication, wireless, multi-hop networks, MN, mobile ad hoc networks, MANET, and wireless sensor network, WSM. And we know what is actually WSM. So success of IoT is only because of the development in the area of wireless sensor network, reliability, security, privacy, and trust issues and solutions, software platforms and services, intelligent data processing and semantic technologies, connecting things to the web of things. Application, system models, standards, and physical cyber social system. Invited industry speakers. This remains a key. Industry university interaction remains a key for any subject to be developed. The current developed in the direction of current requirements. We expect you familiar with hardware system. We expect you know about basic communication networking. So there is a prerequisite in this that you should know basic hardware system. You should know basic communication and networking and a knowledge of object oriented, especially C. So I think by the time students come in fourth year, all this is they have already have these subjects in their course of study. So they are all familiar with these three items. All the slides and additional material will be uploaded to civil, and so that is an instruction we can. I don't let me see. This cannot be located in proxy servers in Sharda University. Anyway. So this is again reading list. Can it go? No. But you can copy this and paste it, and then it will you can do. Then another part of this lecture, Dr. Chauhan has four hardware platforms, networking and security. Office address is given, email is given. You can interact with Professor uh, Dr. Chauhan, and you can discuss. He will be very much happy to interact. So the platform, device level and networking, user environment, sensors and actuators, things, communication, network, gateway, the internet, servers, and then two sensors, IEEE 80, all protocols are IEEE 802.15.4, this is the latest 2.4 gigahertz RF system, and then the internet. Sensor, they are mainly input component. They sense and collect surrounding information. Basically, three types: passive, omnidirectional; passive, narrow beam sensors; and active sensors, sonar, radar. Actuators, some answers are there. The question which I was asking, they are mainly output components. They alter the surroundings. Some example: adding lighting, heat, sound, controlling motors to move objects, displaying messages, and others. We can turn almost every object into a thing. The thing still looks much like an embedded system currently. The thing generally consists of four main parts: sensors and actuators, microcontroller, communication unit, and power supply. The thing has following properties. It is usually powered by a battery. This implies limited source of energy. It is generally small in size and low in cost. This limits their computing capability. It does not usually perform complicated tasks. Power consumption is the main design. It always features communication speed, level of communication, including two nodes, communication type, wireline, wireless, and based communication solutions. IEEE 802.15.4, IEEE 802.11. We are also using in mobile communication, Bluetooth. We are also using in mobile communication and near field communication. RFID is then the most popular use of RFID is in libraries. And the role of network, managing nodes, discovery, join, leave, etc., relaying data packets from source to destination node in the network. Networks are distributed systems. All nodes need to perform networking related tasks. RF-based network in IoT is usually a wireless multi-hop network. Some examples: wireless sensor network, WSN, mobile wireless and ad hoc networks, MANNET, and wireless mesh network, WMNs, and ad hoc networks, WANNet, and others. Main concern: reliability and performance. So internet serves as a wide area networking for a local network. Internet users TCP/IP. This implies that things must also support TCP/IP. At gateway or sink, for a practical deployment, a gateway is often needed in a network. It offers relaying packets between network and the internet. So data link and network, and there is a gateway and the internet. So these are things, application and TCP, UDP, network IP, and similarly physical MAC. Then this is the gateway, the internet, and the server. So this all makes the internet of things. Uh, are they important? What is the risk? What are the challenges? Device level network. These are the questions. Solutions are should come I mean, these solutions, these questions can be shared with the student and let them answer. Becomes an feedback and assignment for these particular lecture. And then there is another which is on software and service data processing and application. So operating system and execution environment, Contiki and TinyOS, relevant protocols and standards, architecture reference models, ETSI M2M architecture and components, gateway and middleware, types of service in conventional communication networks. The target is moving bits from one place to another, and IoT moving the data is not the actual goal. The IoT is expected to facilitate providing meaningful information and action. So this is the sample data communication in conventional network and a sample data communication in WM. So this is the
Hello, sir.
yes, yes. It's
Sir, I have a quick question, if you don't mind.
How to finish? Let me finish one or two more slides probably.
Okay, sir. Okay, sir. Sorry. Okay, sir.
So sensing and data collection, sensor data and data-centric network access, subscription and integration, data processing, stream, data analysis, query and discovery, data classification and clustering. And this is the last slide, Internet of Things. The whole world is in your hand. I mean, this is the each single data then is important, relying merely on data from sources that are unevenly without considering background information or social context can lead to imbalanced interpretation and decision. So something has to be done on this. So multimodal and heterogeneous, noisy and incomplete, time and location dependent, dynamic and varies in quality, crowd-sourced data can be unreliable, requires near real-time analysis, privacy and security important, and data can be biased. We need to know our data. So people want answer, not numbers. Metadata models and schemas, linked data and linked IoT data concept, semantic technology, semantic sensor network, interoperability issues, web of things. I think the application as smart city, smart homes, healthcare, smart grid. This is also a very important area, smart grid, electrical power distribution. The requirement in daytime, the requirement in nighttime is different. So power distribution schemes are there. So we call that as a smart grid. Our electrical department is doing great research in developing, and people are even done PhD on the topic of smart grid. Professor H.K. Verma is the key person, an eminent scientist in the area of smart grid. Suman Lata and Jaiswal, all these faculty members, they are working in this area. Then physical, cyber, social system, machine-to-machine communication, system models and standards. I think this is the end of the slide. The questions now you can ask what question you are trying to ask. Yes?
Tensions. I think in between, one participant is asking a question.
Yeah,
Yes, sir. It was me asking a quick question, sir.
Yeah, continue.
Sir, I wanted to know, like, suppose this network company, taking Airtel as an example or Geo, I was in a location 2 days ago and I had a mobile phone with me, my mobile phone using the same network. So after 2 days, can I, like a government employee, go to the Airtel network and say that at this period of time, at this day, can you show me this area's like points, like pings, who was in this area? Is it possible, sir?
I mean, Usha, can you reframe the question?
Sir, like I'm giving you example.
Yeah.
2 days ago, I was in a location, and after 2 days, suppose a government employee go to a network company and say, I want this location's pings, like the people who are in this location or the signals that you have received from this location without the mobile phone or thing being used at that time. Can the company do that?
Yeah, Mehra sir is asking that without a mobile phone, but in my opinion, without a mobile phone, can a company can give a government can give a data
Sir,
regarding the
ma'am,
location of a
no,
particular person?
ma'am. I mean, we do have the mobile phone, but we have not used it in that particular area at that time.
No, no, yeah, that can be done. That can be done easily.
Is it
That can be
possible,
done
ma'am?
easily. Yeah, it is possible. People can track the basically the according to your mobile number, they can track the location in which near towers you are basically, for example, you are saying that when you're not using your phone, and
Yes.
even you're not using even your GPS is not on, is it?
Ma'am, it's not necessary if the GPS is on or not. Okay, take suppose GPS is not on, because usually people turn off their GPS,
Yeah, if
because of this
GPS is
tracking
on,
issues.
if GPS is on, your location, the location of the person is always detected. Always, if it is on.
Okay, and is this data like from 2 days ago is it stored in their database, in the company's database as well, or is it a temporary, data storation?
Yeah. I think it is possible, but uh, depend on the policy of the company, I think. But
Okay, fair enough. Because
Yeah, basically it depends upon whether we have created, because it's not like that, na, ki that government has created a kind of a WSN network everywhere. Okay. For example, in the future, because it is also related to the privacy of a particular person.
yes, ma'am.
We can't even say that we can have these type of a network everywhere. Okay, we have to basically we can't bother the privacy of a particular person. Yeah, but in a public places we can do, and even in a good good cities where these type of a, because nowadays in Delhi we are having some sort of a camera and some sort of a sensor, they are taking the data. Okay, so it all depends upon the, if there is some sort of a WSN kind of a structure in that particular location, obviously can detect you. Okay,
Okay,
but
fair
if
enough.
that sort of infrastructure is not there, so we are not in position to
Detect.
lead the position. Okay,
Okay,
any
ma'am.
other
Thank you.
questions? So one question I think from the YouTube user. She is asking, sir, one student, Ajra, in third year, she is asking that.
Yes. Question. What is the question? Azra, please speak. Hello. Hello.
Sir, we can hear you, but I think they are phrasing the question.
Okay, okay. Right.
Sir, her question is like Amazon forest fire, we can use WSN to detect the fire early. But what can be the temperature range of the sensor that we can set to sense the fire? Shall I repeat again? Sir, Azra question is like Amazon forest fire, we can use WSN to detect the fire early. But what can be the temperature range of the sensor that we can set to sense the fire?
Yes.
What has she asked?
Thank you, Mehra sir. Actually, there is some issue in my laptop. Laptop hang ho gaya. Okay, thank you so much, sir, for sharing your thoughts. I hope sir
there was
has
a
discussed the
question.
queries from the participants.
Yeah, they can
So,
write email or message and we will
Yes, sir.
definitely
We will
respond.
mail you, sir.
so you can contact Mehra sir. He has already shared his phone number and email ID. Okay.
Yes, ma'am.
And
Yes, ma'am.
FDP participants, please, you may leave the session and you can join the session at next session, day 2, second session at 1:30. Okay.
Okay, ma'am. Okay,
FDP
ma'am.
participants,
Okay, ma'am.
FDP participants, you can leave the session, and VSC candidate, please continue here. We are starting in 5 minutes. All Sharda students and those students who are basically doing the VSC course also, okay, they continue here. Okay, and the FDP participants, please, you may leave and join the same link at 1:30.
मैं जा रहा हूँ अपने उसमें स्टार्ट करो। ये टीम खुल गया यहाँ पे। चेक ये
Okay, again, I'm repeating, FDP participants may leave the session. Okay, and the VSC candidate, please continue here. And please, you all communicate in your groups. For example, if few students are there in your YouTube session, they can also join this meeting. Okay, because now the participants, hello. So in day 2, your value added course of our BTech students, BTech and BSc MTech students, Sharda University. So today, Dr. Shalin Tripathi, he will basically brief you about the evolution of microprocessors. Okay. So, sir, basically, over to you, Shalin sir. Sir, Shalin sir, your slides are
Okay,
visible.
okay,
Yeah, your slides are visible.
okay. Good morning to all. I'm here going to present about the evaluation of microprocessor. So microprocessor is one of the most important component of digital computer, and basically when we talk about microprocessor, the question is that how we relate it, in which device it is applicable, what are the different operations of this. So this is a device that can accept the information, input information, it processes it and gives you the output. It can perform various operations, basically arithmetic logic operations, and definitely it's part of your computer. It acts as a brain. When we talk about these things, some programming, or we talk about the arithmetic logic operations, we have a picture in our mind that we already know about the computer. So if we talk about the basic functional unit of the computer, they are the 4 unit. We all know: input unit, output, memory, and central processing unit. So central processing unit have the component timing and control unit, arithmetic logic unit, and registers unit. So one can ask, what is the difference between central processing unit and microprocessor? So the answer is, in a CPU based system that is given in your diagram, we have all the component in discrete. But when these component, all the CPU component fabricated on a single chip, it is called the microprocessor. So microprocessor is nothing but CPU which is fabricated on a single
शैलेंद्र
silicon
सर,
chip.
सॉरी फॉर द
Yes.
डिस्टर्बेंस सर. काइंडली फुल स्क्रीन कर लीजिए.
All right.
काइंडली मेक इट अ फुल स्क्रीन. थैंक यू सर.
Not okay. So when we fabricate all the discrete components of central processing unit into a single chip, it is called the microprocessor. Now think is that how could it possible? How a picture of microprocessor came into existence? This could be performed with the help of IC technology, by which we can actually fabricate different discrete components into a silicon chip. Okay. Now, what are different benefits if we have a microprocessor, we have a central processing unit? Central processing unit is a discrete component, and microprocessor is in a IC form. So there must be some benefits, there must be some advantages or disadvantages. So number one is power consumption. So if we actually reducing our feature size of the components, basically transistor, then power is also reduced. So definitely when you fabricated your microprocessor, it consumes less power. Second thing is versatility. So this microprocessor, when we are using in a computer, it is basically called microcomputer. So it is basically a hardware component, and we can configure in various applications but we require different software program also or operating system to operate properly. So definitely microprocessor is a very versatile component, and the system which are using with microprocessor, or you can say the system which having microprocessor as its CPU, they are called microcomputer. So if anyone is asking you what is difference between computer and microcomputer, you can answer that in a microcomputer based system, we have CPU as microprocessor. Now, next thing is reliability. So definitely reliability is increased if you are using microprocessor. Now, why reliability is increasing? See, if you have discrete component, there is always a possibility of connections mismatch or problem in connections. You could have experience of, let's say, some discrete component in your breadboard or PCB board. So there you are doing some connections, maybe sometimes they have some fault, but this possibility is reduced in processor. They are designed with very specific data paths or connections, and that definitely increase your reliability. And reliability not only depend on the connections, but the other design aspect, other parts of the design are also important if we consider for the microprocessor based design. They are packaged in a uniform structure. All right. So, and one more thing, if you are going through the component diagram, so
Hello. Hello, Shailendra sir, you're not audible.
I came back, just wait.
Okay, sir. Okay, sir.
All right. So now my voice is okay to everyone.
Yes, sir. Audible.
All right. All right. So we all know about the central processing unit, the components. So central processing unit have the component arithmetic logic unit, which perform all the arithmetic logic operations. Then timing and control unit to having control synchronization of different operations, and definitely control signal for different other units, and some registers. So I think there is no need to tell you in detail about all these. We are familiar. So as I told you, microcomputer. So microcomputer is the computer which uses the CPU as a microprocessor. So that system, like your desktop, present day laptop, all these are your microcomputer. And if they are in discrete components, then we can simply say it's a central CPU based system or simply computer. Now, as per the need of present era, as per the applications, the laptop or desktop, they are coming with multi-processor based systems. Now, why we require multi-processor based systems? Let's say with one processor we having different application, then you can have some issues with speed. Then if we have multi-processor based system, means more than one processor in our system, then we can have different pipeline structures, means our instructions can be pipeline, they can be processed parallelly with more than one processor. So if let's say I have 10 number of application at one time and I have only one processor, then definitely they will be executed one by one. But let's say if I have more than one, two or four processor in a system, then these 10 applications or let's say tasks, they will be divided and definitely your overall speed can be increased. So these trends also came into picture with having multi-processor based system. Now we all know microcontroller. So what is difference between microprocessor and microcontroller? Microcontroller, basically first difference is it is used for dedicated applications, very specific applications. But microprocessor is used for general purpose applications. This difference is related with the application. But if we talk about the hardware based difference, or what are the difference based on the uh, component level, then microcontroller have all the components of CPU plus RAM and ROM, input output port, timer, counter, they are also fabricated on the same chip. Whereas in case of microprocessor, you having RAM, ROM, input output port, they are externally interfaced. So this is the difference. Microcontroller having all these components, means all the components of CPU, then RAM, ROM, input output port, timer, counter, they are fabricated in single chip. And they are used for very specific application like your air refrigerator, like your washing machine. There we have some timing or programming applications you are also using in your projects, Arduino based projects. We are using microcontroller. So in one line, if you talk about microcontroller, so in one line you can say computer on a single chip is called microcontroller. Though it is not a general purpose, but it is for specific applications. So all the components which are required, they are designed on a single chip and they are installed for that device or your consumer electronics equipments. All right. Now I want to explore you some of the parameter which basically roams around all the electronic circuit designing. And these parameters basically, whatever I have written first four, they basically motivate, or you can say provide a guidance sign. And definitely there are some committee, they basically tell about the roadmap for the designing of the electronic circuits or equipment. So as we are talking about the processors, microcontrollers, so definitely these parameters lie here also. One is speed. We all know, if we go back 10 years, what was the speed of our systems, even our mobile phones, you can have a tremendous changes. You can see tremendous changes between these years. Next one is power consumption. So the present trend is to have portable devices. And if we have portable devices, we need some battery operated systems. You can take examples of your mobile phone. So what we actually see, more and more power means duration. Okay, so it means if my device is consuming less power, then definitely the designer will choose it. Second thing, cost. So cost is also a major parameter for the uh, industry people, or for the designer people in electronic industry. So actually, if any company is designing any processor, it need to see the different other manufacturer, and accordingly the company should justify the cost. Then size is also important, as the last session Mera sir also emphasizes about the uh, size of transistors, Moore's law, that number of transistor in packed device or in IC doubling every approximately 2 years. So you can see the complexity of the transistors components. So size is also important. So these are the prime four factors which are governing IC industries. And if you are talking about processor, it is also applicable here. I have added two features, 2 points. One is feature and one is applications. So in uh, processor based design, these 2 points are also applicable. You can see that from the first processor it is invented, and the processor we are using this time, they have tremendous change. They have application wise and other feature also. So I will try to tell you some of the things which could be covered. So if we talk about the some back history of the microprocessors, so the first was invented 4-bit, then 8-bit, 16-bit, 32-bit, 64-bit microprocessor. And I have considered only the Intel processor, which is the leading company for the processor design. Though there are other companies, AMD, Qualcomm, they are also designing the processor. So I and Motorola from last 5 years, I have included the Intel processor. All these uh, design of Intel processor. Fine. So things came up with the picture, but definitely the IC industry and the students should know that how things could come into the picture, portable devices, smartphones. So these people, you can see that first IC invented in 1959 at Fairchild Semiconductor. Okay, in 1968, these three people, they have basically founded, and initially they were at Fairchild Semiconductor, and these three people, they have founded their own company, that is Intel. So it was a three-man startup in 1968. So you can see that in last 60 year how Intel actually grown from three man to billions of millions of people worldwide, and billions of turnover. So I'm not going in that depth, but definitely these three people, they, Robert Nasse, Gordon Murray, and Andrew, they basically founded this company Intel, and then things will proceed. Okay, 4-bit microprocessor. So Intel 4004 microprocessor introduced in 1971. So it can only perform 4-bit operation, arithmetic logic operation of 4-bit. Then clock speed 74 kilohertz, total transistor 2300, and the capability, it can execute around 60,000 instruction per second. So it was the first processor from Intel, and definitely after that many other company, they have also introduced their, but Intel was the leading company from that day to till now. And I'm not saying that other company processor are not using, they are using in some in parallel, but I included Intel Corporation's uh, development on the processor. So up to this, any question from student? Hello.
Any question from student side?
No, sir.
No, ma'am.
Okay, so definitely I will give you the time
No, sir.
at the end of session. Fine. So another version, and one more thing I am telling you, that I have considered the processor from 4-bit to 8-bit. Then the initial feature or primary feature of older version, most of the time they already exist, and they have added the new one. Okay, it not mean that let's say from 4-bit microprocessor to 8-bit microprocessor, they have left all the features of 4-bit. No, they have incorporated that feature, plus they have added some other features. Now I want to tell you very important thing, how actually we are able to add features, which is the dominating part. Anybody can answer? Any student? How could we able to add more and more feature? Let's say we start from here. 4-bit microprocessor, 74 kilohertz, then 2300 transistors, 60,000 instruction per second. It can execute.
So decreasing the size and increasing the speed of working.
Sir, increasing the pains, number of pains.
I'm missing.
See, maybe some of things you are saying right, but I am telling you that if you heard about the IC technology, initially we have LSI, MSI, SSI, then VLSI, and even after we have ULSI. So as per these technology are developed, means we are moving from uh, SSI, small scale integration, to medium scale integration, then large scale. So this is not a one day task. If you are if you are talking about any foundry which is making the IC, every component need to be updated. Let's say if somebody of you heard about the basic process of IC fabrication, photolithography, then let's say my initial feature size is 0.5 micron or channel length of transistor. So channel length, let's say 0.5 micron, and then I switched from 0.5 micron to 0.18 micron. So it could not happen in just a button. All the equipments which actually having cost of millions of dollar, they need to be updated, replaced. Then only you can actually have the another node of technology. So one can ask, sir, so who actually guide, who motivate? So there are some parallel things going on. I will take 1 or 2 minutes to tell you this particular thing, that there is a ITRS, International Technology Roadmap for Semiconductor. This society is there, and they basically have some survey, have some interaction, and they also estimate that, let's say, in next 5 year, what is required in market, next 10 year, what should be change, what people like, what is the demand. Accordingly they made the policies for the IC industry. So ITRS is one, maybe some other there. So they make policy that in next 10 year these things should be updated. Accordingly, the manufacturer or company, they are investing in that direction. So economy and market basically motivate everything here also. In IC fabrication or processor fabrication, here also, that roadmap, market requirement and estimation, they actually motivate the direction, what is the demand. So okay, now I will proceed. So next version, Intel 4040, again it was a 4-bit, and it is introduced in 74. So all these features are there, but with few advancement I have not included that. I have included in the 8-bit processor, which are actually came into picture in 1972. So from 4-bit to 8-bit, it means now your data handling capability is 8-bit. Your arithmetic logic operation, I am try to explain you in very simple word. Let you have you can do an addition of two 8-bit numbers. You can pen and paper, you can add, you know how to add two binary numbers. So now your capability of processor become 8-bit. And I want to tell you, if you are not knowing, in our processor and microcontroller lab, we have 8-bit microprocessor, that is 8085. That kit we have. For microcontroller we have 8051, that is also 8-bit microcontroller. And you can access those kits, you can write the program, you can store your program in that kits, and you can check your result also. So here in your lab you have these two kits. Okay, so we are talking about 8-bit. Now just compare for 4-bit feature size to 8-bit, here we are actually enhancing the speed also, 500 kilohertz, and then 50,000 instruction per second. Now just compare. I think something is maybe some data may be mismatched, but clock speed definitely we are increasing, data capability we are increasing, and just give me an opportunity to come with 8085. Just I think there is some mismatch here. Here we can see this is another version 8080. This is also a 8-bit microprocessor. So 2 megahertz clock speed, 6000 transistors, and you can see 10 times faster than 8008. So next version, this is 10 times faster, and here you can have 5 lakh instructions, or 5 million, sorry, 0.5 million instructions per second. So definitely your instruction capability is increased, speed, number of transistor, clock speed, and data capability also increased. Now we come to 8085. So this was very popular at that time. Even we are studied this time also 8085 and 8051 microcontroller we are studied. So it is invented in 1976, 8-bit processor with 3 megahertz clock speed. Now here we have 8-bit data handling capacity and 16-bit address capability. Now address bus is actually take the address information to interact with your memory. Just like let's say in your SCT you have room number for that recognition. Similarly, each memory cell recognized by its unique address. So initially we have address information. It is sent from the processor to address bus, and then it is being recognized. Some control signal, they activate your memory, and you can actually read or write the instruction, read or write the data on the memory. So 8085 have 6500 transistor, and you can see speed is again instruction execution per second, it is increased. And for address accessing capability or your memory capability, it is 64 KB. Okay, and it has total 246 instructions, means total instruction 246, and you can use in your programming these instructions. So it was very popular till time we are reading. Yes, we are reading other processor also. All right, so in the next few slide I will tell you definitely some other versions of Intel with 16-bit, 32-bit, 64-bit. But the major feature I told you that these are the parameters. So if we keep in mind that every time the next version having with some increased features with speed, power actually reduced, and if you talk about the transistor size, single transistor size, it is also reduced. Cost wise, it is also reduced. You can see that feature are actually increased and cost is reduced. Applications are increased from very simple processor to your multimedia processor, gaming processor. All they are having even one more thing I want to include. This time we have in advanced processor with some virtual memory or that segmentation, pipelining, all these having with some advanced processor. Initially, we don't have these capability. So our the discussion will be uh, in the periphery of all these parameters. So after 8085, Intel introduced its 16-bit microprocessor. Whenever we are talking about 8-bit, 16-bit, it always relates with the data capability or data handling capability. So it was introduced in 1978. Now from the invention of year or this year, you can also see in 1971 when you introduce your 4004, you have I think only 2000 some 300 transistor, and you can see here 29,000 transistor in just delay of 7 or 8 years. So how you can see electronic industry is changing, and complexity is increasing. You can compare from this. So clock speed is also again increasing. I want to tell you one thing, that clock speed is increasing is not only one factor that you just include a high speed oscillator. No. For that particular speed, if you are increasing every parameter of design, I am including some of things like memory transition time, that should also be reduced to just comply with this much of speed. Your data paths, your buffer register, and your ALU, all these need to be redesigned if you are increasing your speed. It is not only that you just remove 2.5 megahertz oscillator and you include 10 megahertz. No, device will not sustain. You need to redesign, you need to develop every part from your register to ALU to your memory. Everything need to be redesigned accordingly what actually you want to have the speed. So processor design is very complex. Each and every part, actually we initially any design engineer, they actually write the specification, then the task is divided to the core team of different specialization. Let's say I am taking just one example, then you could have a picture in mind that let's say how a processor is being designed. So it having definitely hardware part, also it having software part also. So let for this 8086, I have listed these specification, and this was the starting thing. Then let's say what should be done. So initially, this is being divided. Let's say one team is for memory design, one team for your ALU design, one team for your register design, one team for your critical path and data path, just like you can say routing and all those. So when we talk about the VLSI design, there we have different parts like logic design, then system level design. So each part is divided. One team is for only for OS or software development for that particular let's say for this 8086 or other. So one team is only designed for that, so they have only programming either in C or either in VSDL. So they design that part. So when all these teams actually complete their task, then things will be compiled. And for fabrication of IC, initially everything tested with simulation. When everything is tested with simulation, then layout is fabricated, that is also on software. So definitely we require very sophisticated software for the design of any electronic component related with like processor. So there is a complete tool for design, cadence tool. Start from the circuit. So we start from the circuit design. Electronics people can understand that let's say you have some op-amp based circuit, you have op-amp, some resistor, capacitor. So circuit simulation you do. Okay. After that, this team proceed to physical design. So you are writing SDL code for that. That SDL code is also tested. Then layout, partitioning, all these things are done. Further, this information sent to the manufacturer, and then manufacturer they basically uh, built on the silicon chip, and there have some standard process. So that is not the part of topic, but I just consider for this how we proceed. We proceed with start with circuit design and then come to silicon part. All right, another 16-bit Intel 8088 introduced in 1979, and they say that it was created as a cheaper version of Intel 8086. So means you have this 8086 16-bit, but they created with some features, maybe some 16-bit processor with 8-bit external bus. Here what you have, 16-bit data bus, address bus 20 bit. So actually they minimize some features and definitely cost will be reduced. So all right, then there again 16-bit 80186, 80188, some clock speed. Let's see here, what is the clock speed here? 4.77 megahertz, 8 megahertz, 10 megahertz. They are the three versions in 8086 16-bit processor, but here they give with 6 megahertz. So 16-bit processor with some versions, again 80286. Now they also tell about the feature size here, 1.5 micron process, 6 to 12 megahertz of speed, then 60-bit word size means again your register size, then 68 pin package. This is available in 68 pin package and 8-bit megahertz of clock speed. Fine. And here you have 134,000 transistors. After 16-bit means you up to this time you can actually have the data handling capability or that operation of 16-bit. Now Intel introduced 80386 in 1986, and it was a 32-bit processor. So you can see your data capability just doubled, and the difference, time difference, 4 years. Okay, let me compare about the transistors. 134K transistor in 1982, and now you have 175K transistors. And about the Moore's law, it is not actually mandatory that just double in just 2 years. No, it can be some plus and minus. Maybe some part you can observe that number of transistor even double in 18 months and sometimes in 24 months, and this time, and I think more than that, more than 2 years. So it was at just as approximation. So you have now increase your data capability, and this is now 100 pin package. There you have, I think, less package 64 68, and definitely when you are increasing your number of transistor, you are increasing your capability, you are increasing your applications, the pin also increases. Then Intel 80486. So now clock speed again increased. Feature size, you can see feature size is decreased. Okay, 1.52, you increasing from 1 to 0.6 micron process. Then 1.2 million transistors, means you are actually packaging more and more transistor. That what I asked, which part, which actually parameter motivate you to inbuild more and more applications. So definitely feature size of transistor, and or you can say in other word, number of transistors. So when you actually increase number of transistors, you could, because the basic element of any electronic design is transistor. You are doing analog design, you are doing digital design. You can see by flip-flop, you can make a sequential circuit or you can make a combinational circuit. Even for your memory design, you need transistors or flip-flops. So if you are packaging more and more number of transistor, it means you are increasing more and more memory capability in other applications. If even you can compare that, if you compare from last 10 year about the memory capability of desktop computer, even RAM and RAM, hard disk both, processor speed, present time, and 10-year back. So you can see this. So this could not be done in one day. There is a complete team, and they are doing continuously their efforts to improve or to enhance the capability. They are not stopping. Means let's say in 2020 they are just launch some version, then they have their own target for next 2 year or next 1 year with some new version of processor with increased capability in terms of speed, in terms of memory, RAM, ROM, everything. All right. So it is introduced, 80486 is introduced in 1989, and the frequency from 25 megahertz to 100 megahertz, and this is available in 168 pin package, 1.2 million transistors. Then this is the Pentium, very popular, and some of you I think already heard about it, maybe Pentium processor. And if not this, then Pentium 4, next version of this. They are in 32-bit, and the original name is 80586. But this name, Intel Pentium, it was more popular. So here we can see that for every aspect of the design, if you talk about here this 0.8 to 0.35 micron process, this is actually the transistor feature size or channel length, 0.35 micron. So every time we are reducing the feature size, we are increasing number of transistor, we are increasing the frequency, we are increasing word size, and the other feature, other capability. One thing I want to introduce, just compare between 8085 and 8086. Initially in 8085, if I want to execute a program, your program is executed one by one instruction. But in 8086, they introduced a instruction queue. 6-byte instruction queue they have introduced. So what is the benefit of this 6-byte instruction queue? So parallelly, when processor is executing the program, at the same time, instruction from memory, they are actually saved in the instruction queue. So time for your opcode fetching, or your code is fetching from memory to your instruction register, that is being reduced because you have actually instruction queue. Similarly, in 8086, they have segmentation of memory. I will explain. Segmentation of memory, they introduced that let you have address information, data information, code information, stack information. In 8085, it is in one memory. But in 8086, your memory is segmented depending on the type of information. So how it is segmented? Code segment, data segment, stack segment. Now your one type of information is stored in there. Let's say for stack segment. For data segment, you have for data you have data segment. For code you have code segment. But in 8085 you have only one type of memory for all. Similarly, in some advanced processor, you have included the pipelining. So to reduce the your actually total operation time or execution time. So other version, I'm not telling the other details, but they are just versions of Intel Pentium Pro introduced in 1995. Maybe some of you were born on that year. So this process technology is there. Okay, 166 megahertz to 1000 megahertz. Then transistor 5.5 million to 28 million. Okay, Pentium 4 introduced in 2000. This could you hear about it. Now from micron size feature size to they come with the 180 nanometer to 90 nanometer feature size or process technology. Okay, based on I think CMOS, complementary MOSFET, metal oxide semiconductor field effect transistor. So from micron 0.5 0.35 micron to they come to 180 nanometer or 90 nanometer feature size. Again you can see 42 million to 125 million. Now your clock speed come with gigahertz, 1.4 to 3.4 gigahertz. Okay, and you can see number of pins. So how design is complex and how it is very critical to design the processor. There should no short circuiting. There should be heat management or heat dissipation. Okay, power consumption. All these things are actually considered. So processor design is not a one-man task. It's very complex. Hundreds of parameters are being specified, and basically on that people are working as a team, and then we could actually have this type of devices. And modern day processors with your laptop and desktop could be possible, your smartphone could be possible with this type of features and advancement. All right, now now here I want to emphasize that in 2006 Intel given a dual core processor. Means now in one system it introduced two processor. Okay, Pentium dual core. So how things is there? Core 1, core 2, bus interface, and so your task actually divided, and overall speed is increased. Now from this trend 2006, 2 core to you have 4 core, 6 core, 8 core, they are available. That's why in one system you can have multiple applications in a time and they are not going to slow with good speed. So to speed up your operation, this trend introduced in 2006 with multiple processor in one system. Okay, so after this 64-bit microprocessor introduced in 2008. Now your data capability is 64-bit and Core i7 processor. Okay, 6 cores means 6 processors are there and your speed increases from 2.66 gigahertz to 3.33 gigahertz. And after that, I think I have not included. Yes, i5 introduced with maybe just wait. They have different version from 1.9 gigahertz to 3.8 gigahertz. So it is, I think I should now conclude. Time is up. So this is just, I try to include some of the evaluation and I take in consideration about the Intel processors and I try to include the features which are actually motivated the designer, industry people or company and their impact in society. Just I told you how things are updated and product is came into our hand. So I conclude my session. Thank you. Now any question from students?
Any questions from the student side? Any queries? Thank you very much, Shalendra sir. Yes.
Sorry, it's Hamid sir, Chitra ma'am. Sir, I had a question. Like recently, we have the Bionic chip of Intel. Apple used in their iPhone, recent iPhones. They hold about 5 billion transistors,
All
as
right.
they have mentioned it. Well, we're not sure. We haven't checked inside yet, so it must be true. Plus, they reduced the size to about 5 nanometers.
Yeah.
Like I think that's smallest possible, and even I don't think a human eye can detect that unless it had to be seen through a
Yeah.
a microscope or something.
When we are going for nanometer, we can't see.
Yeah.
We
So,
can't see
sir,
by.
how is it possible? Do they use like machinery to build these transistors, or
Yeah.
the designers, as you said, it's all practical. They have to design it through
See,
softwares and all that.
any processor, even with the starting processor, that cannot be handmade. They are with very specific instruments. Okay, very specific instruments. Then they are actually programmed, and accordingly in silicon chip, things are fabricated. So with a well prescribed parameters and format steps, they are very defined steps for the fabrication process, and they are automated, equipped with very specific equipment, not by human hands. Not okay.
Okay,
Though
sir.
though humans are there for supervision, for programming, for inserting parameter, all that, but very specific and prescribed equipment and softwares are there to check the quality. Even after fabrication, all the chips are going for the testing.
Yes,
If
sir.
any part at any point, any pin is malfunctioning, it is just discarded. So after during design, during simulation, during your layout design, each step is being tested. After that they actually proceed for the next phase, and when actual IC is fabricated or actual microprocessor is fabricated, that has also been tested. Okay.
Yes, sir. And sir, to your knowledge, like how far can this take us? Like it's 5 nanometers now, so it's very much small, you know.
Yeah.
But do you think that it can go farther, like smaller than this even? Like
Mm.
it can be like a very tiny chip could do like a very massive functions.
No. When actually I am telling you, there are various effect when we are actually reducing the feature size. So when we cannot go beyond the atomic size, okay. Some atoms they are from 3 to 5, 7 nanometers. So we are not go beyond that. We cannot go beyond that. Somewhere we have to stop, and I think 5 nanometer, I have heard about the 7 nanometer they have fabricated with FinFET technology. So maybe 5 nanometer with some advanced technology they could be fabricated, but we cannot go beyond that. We have to stop somewhere. But the solution is, let's say somebody is asking, after going to 5 nanometer, could we increase the speed? So answer is yes. I am telling you the answer, that let's say I am using silicon. So silicon have own property of mobility and carrier speed. Let's say I am going to switch some advanced material like mm, CNT, carbon nanotube, or graphene. They have better speed, even the same feature size. So somewhere we need to stop, but we have to see the alternate material, alternate technology to sustain this electronic industry.
Yes, sir. Understood, sir. Thank you very much.
Okay.
Is there any other queries? Thank you, Shalendra sir, for giving
Oh,
the valuable and informative session for the students on the evaluation of microprocessor. All
thank you,
the
ma'am.
students, thank you, sir. All the students must participate, resume at 1:30 p.m. sharply. Okay, thank you.
Thank you, ma'am.
Okay, man.
Yeah, good afternoon. Anandita, voice ठीक है मेरी? हाँ. Anandita? Hello, Anandita?
Yes, ma'am. Yes, ma'am. Your voice is clear and audible too. हाँ मैम धीरे धीरे कर रहे हैं
Hello.
Yes. Yes. Tamam Zen.
Hello.
Yes.
Hello.
Okay. Yeah. Abhishek sir. Yeah. Yeah.
Good afternoon, ma'am.
Yeah. So, good afternoon, everyone. So, I welcome you all in the day two, session two. So, today we are having with us Mr. Abhishek Gupta. He is Assistant Director, Enterprise Business, ALTCC, Ghaziabad. Okay, so before starting the session, I will like to give the brief introduction. So, Mr. Abhishek Gupta, presently he is working as an Assistant Director at ALTC Ghaziabad and has obtained his bachelor degree in Electronics and Communication Engineering from GBPEC Podi Gadwal and Masters in VLSI Design from UPTU Lucknow. And presently he is pursuing PhD in 5G Communication Technology from SRM University, Chennai. So he has been associated with Bharat Sanchar BSNL since 2009 at various locations, namely as Jaipur, New Delhi, Noida, and finally he has posted to the ALTC Ghaziabad in year 2014. So since then, he has been involved in providing the training to various BSNL officers, APT, ITU, CTO courses, and summer industrial training for the BTech students in telecom technology field and much more. So over to you, Abhishek sir. Welcome to this particular event, faculty development program on wireless sensor network and IoT. So please continue.
Good afternoon, ma'am. Thanks all the participants. Good afternoon to all of you. Myself Abhishek Gupta from ALTTC Ghaziabad. मैम पीपीटी तो आपकी तरफ से शेयर की जाएगी ना?
Okay, okay. So, okay, sir. Just take a wait for 2 minutes.
मैं जैसे मोबाइल पे ही बैठा हुआ हूँ तब तक मैं इनको.
Okay, I'm sharing.
Okay, ma'am. So ALTTC is Advanced Level Telecom Training Center, Excellence Center of ITU, Center for Excellence of ITU in 3 fields: fixed mobile broadband, IoT, and cyber security. So ALTTC is providing training to participants of Commonwealth Telecom Organization countries, ITU countries, APT countries, Asia Pacific Telecom, and ASEAN countries. Recently, we have provided training to Nepal Telecommunication, more than 100 officers. So this training center is basically for ITS officers. But nowadays, we are providing training to students also. So students of Sarda University, I think they have taken training in 2018 and 19. Since 2020 was COVID affected. So this year, Sarda University students, since facility is not available for offline or classroom training, so they can take training online. Training of online training is endorsed by AICT also and its portal. So we are providing training to NIT Srinagar, GBPUT Pantnagar, BTKIT Dwarahat, and GBPC Pauri Garhwal. Online training. We have trained more than 1,000 students during COVID-19 from these colleges. We are also providing training to IRDT, Institute of Research Training and Development, Kanpur. So they have empaneled ALTTC for training of polytechnic teachers. So more than 1,000 teachers are taking training online from ALTTC. So technological development, globalization, and communication in telecom have brought inevitable tough competition in the telecom sector, nationally and internationally. This in turn has. Hello, are you listening me? This in turn has spared vendors and services provider to have a serious relook and review the whole gamut of management to devise strategy to select technology, plan, desire, ROI for excelling in competitive scenario. Training plays a vital role in keeping the operation competitive. ALTTC has over 3 decades of experience in the field of training in telecommunication. The institute has been catering to the diverse needs of international as well as national telecommunity. Here, we help you identify areas of concern in your organization where expertise of our center can be leveraged for growth. We at ALTC to strive to realize our vision, deliver excellence through training. So these are some PPTs.
Just a minute, Abhishek sir.
I have. Okay.
Abhishek sir, I shared my screen. I hope it's visible to you.
Yes, ma'am. It is visible.
Okay.
So this topic is mobile communication towards 4G. So next slide, ma'am.
History. आप देख पा रहे हैं सर? Are you able to see?
जी 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 बिल्कुल. नेक्स्ट पीपीटी मैम, क्योंकि यहाँ मैं जरा मोबाइल से चला रहा हूँ तो उस समय बाहर.
Okay, okay.
जी.
Then cellular concept.
सेलुलर कॉन्सेप्ट, क्योंकि ये डाटा मोबाइल डाटा से ही चल रहा है ये वाला.
दिख रहा है सर आपको? हमें तो सर प्रॉपर्ली दिख रहा है. नो इशू, कोई इशू.
मोबाइल कम्युनिकेशन टुवर्ड्स 4G. दिस इज द फर्स्ट स्लाइड. So next slide is
सेल स्ट्रक्चर.
जी 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 वो विजुअल नहीं हो रही यहाँ से. नेक्स्ट स्लाइड जो है, नेक्स्ट स्लाइड यहाँ पे सही शो नहीं कर रही है, फर्स्ट ही दिख रही है.
अच्छा, नहीं हम दिख नहीं रही आपको. चेंज नहीं हो रहा. एक ही दिख रही है, सेकंड आ नहीं रही. So just hold on, मैं दोबारा शेयर करती हूँ इसको.
So ALTTC deals in different projects. So there are few projects: the study of GSM Nokia equipment, architecture and functionality, planning and design of 2G radio networks, 3G radio networks, antenna system in cellular mobile networks, radio network advanced features, 2G and 3G parameters. जी जी अब आ रही है. So planning and design of 3G radio network, call flows in mobile cellular networks, optimization of mobile network, compare and contrast prepaid mobile tariffs of BSNL and other operators such as Reliance, Airtel, Vodafone, Idea. Comparison of different types of services provided in mobile by BSNL and other operators beyond 3G, HSPA, and 3.9G LT and 4G LT Advanced.
So just wait a minute. I'm sharing it from another PC. Might be some issue in this. Just few minutes.
Okay, ma'am.
Yes, Anindita, it's visible here.
It is visible. First slide is visible.
Yeah, first slide is visible. You change. Anandita, change. Next.
Okay.
I think.
This one is history. So in mobile communication, there are different generations. First generation was analog. It is totally voice oriented. And there are three different standards. Nordic mobile telephony in Scandinavia, and AMPS, advanced mobile phone system in USA, while European system. So we are following European system, and in this was totally analog, while second generation was digital. So performance was improved due to digital, and it was for voice with video with slower speed. So there were some special facilities such as SMS, etc. And now we are using 3G and 4G and going for 5G also. So in case of 3G, it was also digital, but in this case, voice with video with higher speed, voice data and video with higher speeds. And in case of 4G, cost per bit is also very low. So we are getting wide content, video, live streaming at higher speed. And 4G equipments are very compact equipments. You can install it in a single room and you can deal whole territory, or we can say LSA, license service area. LSA means license service area. At UP West is license service area, and NCR region is also license service area. So there are 23 license service area in India, 21 under BSNL and 2 are under MTNL. So other operators are also using these LSAs. So there are some fixed fee, licensed fee, which is in crores. So BSNL paid 14,000 crores license fee, while BSNL had got a spectrum of 3G. 4G spectrum is still awaited, although at some places 4G slide is okay. 4G services are still going on 3G spectrum, but difference between 3G and 4G equipments are that 3G equipments are bulky and 4G equipments are very compact, and they can cover they can use different technologies, MIMO technology, multiple input, multiple output antenna, LTE advanced technology, long-term evolution advanced. So by using 4G, someone can get better services in sense of data. And this type of now 4G uses two types of switching, circuit switching and packet switching. So mainly packet switching is wide portion in case of 4G, while in case of 3G, circuit switching is also major part. So in case of 4G, there are some special advantage that software flexibility is more as compared to 3G, and most of the functions are software controlled. So this technology is useful, although there may be some harmful radiation also at higher frequency, because frequency is high as compared to 3G. But basic structure of 3G and 4G, there are some different entities. Hello.
Yes, sir. So in between, your voice is little.
Actually, they are okay. Actually, there was some telephone call. So in telephone call, it may interrupt signal. So in case of 3G and 4G, so basic architecture in case of 3G, there are three different parts. One is BSS. BSS means base support subsystem. Another one is NSS, Network Switching System. And third one is OMC, Operation Maintenance Center. So BSS is that portion which can be directly seen by the user. It consists of BTS as well as BSC. BTS is base transceiver station. Base transceiver means transmitter plus receiver station that can be seen at any place and where it is installed. And BSC is a device which controls the BTS. BSC means base station controller. Base station controller controls the BTS. One BSC can control up to 16 BTS. So in case of BTS, BSC is used for radio resource management, while BTS provides radio link to different terminals. So in case of 3G, it is called mobile equipment, mobile station. Mobile station means mobile equipment plus SIM. So mobile station consists of mobile equipment plus SIM. SIM means subscriber identity module. So it consists of different key for authentication purpose to avoid any fraud or cloning. While mobile equipment can be identified IMEI number. So everyone knows about that number, which is hardware number for particular mobile. So I think these PPTs which are showing you, these PPTs is for cellular concept. So cellular concept is related with the pattern of mobile station. मैम आप इसको होल्ड रखिए आप, ये चूंकि जो हम बता रहे हैं ना, ये इसमें पीपीटी में बहुत ज्यादा नहीं होगा क्योंकि पीपीटी भी एडवांस है और ये मटेरियल भी एडवांस है, तो इतना सारा टाइम नहीं है अपने पास शायद।
ओके 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 ओके।
तो ये जो कि बेसिक है, लोगों को समझ में ही नहीं आएगा अगर हम लोग डायरेक्ट बताने लगते हैं। अब वो इतना वो नहीं था, नहीं तो हम अपने लैपटॉप पे बैठ के खुद समझाते हैं, जैसे अलग से लेक्चर रखे ना तो वो फिर हम कर सकते हैं कोई स्पेशल टाइप का जैसे हो, तो उसमें पूरा बेसिक पीपीटी वगैरह आ जाए। हालांकि मटेरियल अच्छा आपका रिक्सन का मटेरियल है, लेकिन वो है आपका। तो मेनली इन केस ऑफ BTS, BTS may have different power ratings. So if there are heavy BTS, transmission power is
हेलो अभिषेक सर। अभिषेक सर। हेलो अभिषेक सर, your voice is not coming. हेलो अभिषेक सर। Yes, participants, there might be some issue. Just wait for a few minutes. Abhishek sir.
Okay, ma'am.
No, sir, your voice is not audible. Abhishek, sir, your voice is not audible to us.
Ma'am, his screen is overlapping here.
Try to reconnect.
Yes.
हाँ लिख भी
आनंदिता वो प्रेजेंटेशन वाला वो चूज कर लो आप हेलो
हेलो
यस
हेलो
अभिषेक हाँ अब आ रही
हाँ
है सर
आवाज आ रही है आपको
हाँ
अब
हाँ
वॉइस आ
सर
रही है? जी जी जी
अब नाउ इट्स कमिंग
तो
बट इन बिटवीन आपका बिल्कुल बंद हो गया था वॉइस
जी जी जी
ओके सर प्लीज रिज्यूम एंड प्लीज लेट अस नो जब आपको स्लाइड चेंज करना है ओके
जी 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 so we were talking about BSS system. So BSS consists of BTS and BSC, and between BTS and BSC some important unit is also there, TRO. TRO is a transcoding unit which decides the coding rate. So between BSC and BTS there is some specific unit TRO, and I have already told that BTS is responsible for radio link. So BTS connects the mobile station. Mobile station consists of mobile equipment plus SIM. SIM is subscriber identity module. And to avoid any cloning of SIM, there are some authentication processes. So there are different channels which are stored in SIM. BCCH, broadcast control channels, and there are some keys, authentication key and SIM key, which is called KIKC ciphering key, and there is some algorithm A3, A4, A8 algorithm. So by using these keys, SIM can be authenticated. So there are some specific response which is generated by SIM after getting some random number from network side to avoid any hacking. Suppose in network side, since same parameters are stored with respect to particular SIM which is for MSISDN. We call for MSISDN, mobile subscriber. MSISDN number is that number which we call for connection. So corresponding to this number, this SIM, there are some specific parameter which is also stored in network side. So network side with some specific device which is called home location register, HLR. So HLR is a permanent database. So corresponding to that particular SIM, it generates some specific random number. The random number is transmitted through air, and particular mobile station receives this number, and in response to this number and parameters, after processing parameters and this number, a response is generated which is called send response, SRES. After generation of SRES, it sends SRES to network side. So there is some authentication device, authentication center, which is linked with HLR, home location register. It can verify that it is same user or not. So if authentication is successful, then particular user can be connected to network side. Otherwise, it generates message authentication failed, registration failed. So this is security parameter. And in case of BTS, there are different types of BTS. Low high power transmitter, maybe low power transmitter, medium power transmitter, micro BTS, nano BTS. So in case of high power transmitter, coverage is up to 10 kilometer or more. So these BTS are high power BTS. And in case of medium BTS, they can cover in 1 to 1.5 kilometer. And in case of micro BTS, they can deal only with few half a mile diameter range or less than that. And pico is for particular building or for particular building inside a building. And in case of tunnel, we use different types of selective cells. So selective cells is used in tunnel.
और क्या
Abhishek sir. Hello. Hello, Abhishek sir. Yes, participants wait for a while.
Hello. Hello.
Yeah, Abhishek sir.
हाँ
Okay, sir.
Yes, other audience, please mute yourself. अभिषेक सर वॉइस नहीं आ रहा है अभी. अभिषेक सर.
हेलो हाँ गुड आफ्टरनून हेलो गुड
Yes,
आफ्टरनून
yes. हाँ आ रही है आवाज सर. Actually, I think it's you're muted from your side. Yeah.
okay so actual so we were talking about mobile future trends. Hello.
Yes, sir. You are audible. Anandita, share the screen. Yeah.
Okay, ma'am.
Hello.
Yes. Abhishek sir, you are audible.
So we were talking about BTS. BTS is base transceiver station, and we were talking about cellular system cells. So there are different types of cells: micro cells, macro cells,
इसमें क्या लिखा है उन्होंने?
selective cells.
Anandita, mute.
हुआ है तो मैं आपको बुलाता ना, मैंने नहीं बुलाया तो इसका मतलब ये था कि मुझे मतलब सही वो था. मैंने कहा सर हम वो लोग हैं जो हमेशा हॉस्टल में रहते हुए भी सवा 8 पे पंच कर देते थे, है ना. सबसे पहले ही आती हूँ सर मैं डिपार्टमेंट में. अभी तो फिर भी थोड़ा टाइम का रिलैक्सेशन हो रहा है तो चलो ठीक है, वरना सबसे पहले मैं ही आती थी डिपार्टमेंट में. प्रीति मैम आती थी, अनीता
Okay. Abhishek sir, voice नहीं आ रहा है आपका.
Okay. Ma'am, now voice is coming now.
हाँ sir, बिल्कुल. Now
So
it's fine.
this one is suitable place. I think air signal is proper. So we were talking about different types of cells: micro cells, pico cells, selective cells, macro cells. So macro cells is up to more than for 10 kilometers, while microcells is for half a mile, and picocells is for uh, building, and selective cells are for tunnels. So advantage of selective cells, which is not written here, advantage of selective cell is that a cost and frequency can be saved, because there is third dimension is missing dimension. So there are only two dimensions. So two orientations are sufficient in case of tunnel. So by using selective cell, which is a special type of cell, cost of frequency, that is spectrum, and one dimension can be saved by this. So frequency can be utilized elsewhere. So one important thing is that which type of cell should be used where. So in case of mall where we have to use only repeater or someone else for amplifying the signals, you can simply use picocells or repeater. While in case of microcell, which is densely populated area, we can use microcells. While in case of rural area where there are few users, user density is less, then we can use macrocells by designing criteria. So one can ask question that why we are using microcells or microcell for densely populated area, that is a small coverage area for uh, large public density. So it is due to the fact that there are very since frequency spectrum is very limited. So in case of broad communication, mobile communication, only 25 kilohertz band, 25 kilohertz bandwidth is needed for one-way communication. So for transmitter to receiver, 25 kilohertz bandwidth is required. From receiver to transmitter, 25 kilohertz is required. So for serving one customer, 50 kilohertz bandwidth is required. So if you want to serve 1 lakh customers, then 50 kilohertz into 1 lakh, that is 5 gigahertz bandwidth is required. So this type of huge bandwidth is not available in case of mobile communication. So we have to reuse the frequency. So for reusing the frequency, we can use some specific, some low power type transmitter. In case of FM broadcasting, same spectrum can be used in Bombay, same spectrum can be used in Bangalore, same spectrum can be used in Delhi and some other places. It is due to it is the advantage of limited reception. That is, if reception of signal is limited up to a certain distance, then this type of frequency band might be used elsewhere, uh, because there will be no interference. In communication, interference is important design criteria for designing the equipment, using the equipment. So there are three facts: noise, interference, and distortion. Noise is unwanted introduction of energy that falls within the desired band of the signal, maybe internal or external. Everyone knows in engineering field. While interference is mixing of the signals having same bandwidth. So this is the important criteria. And distortion is the shape change of the signal due to non-linear amplification. There may be some harmonic distortion or intermodulation distortion. So interference is an important fact in cell design. So if we are using low power transmitter, same frequency may be used to some other places. So as in earlier slides, there are different types of cluster system. Cluster means a group of cells. Suppose there are 7 frequencies A, B, C, D, E, F. C, D, E, F. Then cluster of 7 means there are 7 different frequencies that can be used for serving a particular customer or particular area or particular group of customers. But these 7 frequencies are although different from each other, but these 7 frequencies may be used to their adjacent places by avoiding interference by some rotation criteria. Suppose there is a frequency. Just near to a frequency, there might be B or C frequency or some other frequency other than A. And nearby B frequency, except B, some other frequency may be used adjacent to that boundary. So this type of cluster, maybe 7 frequency cluster, 4 frequency clusters, 12 frequency clusters, or some other pattern may be used. So this type of cluster is useful in case of telecommunication. Suppose in Greater Noida area, uh, a particular area, a particular frequencies which are used for 500 meter or 1 kilometer. So in adjacent location, just you can use same frequency. In other places which are adjacent to these two places, by rotation of frequencies and avoiding interference, you can use these frequencies for serving more and more customers. So why we can say that these 7 frequencies or particular frequencies which are used at one place, you can use at another place. This concept is called reuse of frequency, because we have no extra frequency. Spectrum is limited and cost of spectrum is very high. So this is the dispute of telecom, that spectrum, because cost is very high. So there are three different types of cells: macro, micro, and um, selective cells or pico cells. But nowadays we are using some specific type of cell, umbrella cells, because in highway, if you are maintaining the call, since there are two criteria. One is when you are moving, but you are not connecting with any BTS in by traffic signal, that you are not talking at this time. But if you are talking at this time, you are using traffic channel also. So if you are using traffic channel, then there is a problem that the connection should be maintained from one place to another place. So if you are moving in highway and speed is very high, 100 or more per kilometer hour, then there may be chance of breaking the signals with several disconnections from particular BTS. So there is some umbrella cell. Umbrella cell can serve a customer from 30 to 35 kilometers. So if speed of vehicle is just more than 100 kilometers and significant speed that vehicle is moving at fast speed, then in highway, handover is given to umbrella cell, and by using umbrella cell, one can talk 30 to 35 kilometers, hence he or she can avoid call drop. So this is the new technology. And for checking out the signals, whether it is black spot or signal is proper at that place or not, there are some different tests, which is called drive test. So there are two different equipments. By using these two equipments, comparing with each other, signal is tested. By testing of the signal, uh, cell can be designed, because ideal type of cell is hexagonal cell. Someone think that electromagnetic pattern, yeah, cell pattern, signal pattern, which is transmitted through a BTS, may be in circular form, but signal is not either not in signal cell size is not in circular form or not in hexagonal form. If you are using hexagonal form, ideally, then there will be no black spot, there will be no interference, no overlapping of cells, signal will be better. But ideally it is not possible. Practically it is not possible to design hexagonal cell. Internet option in aeroplane. In internet option may be used in aeroplane by satellite medium, and one specific technology is coming. My GM, which is in Inmarsat. Inmarsat is situated in ALTTC and responsible for providing satellite phones. Someone asked this question: we can use in aeroplane or not? So yeah, nowadays we can also use internet in aeroplane, and aeroplane is also guided by the satellites. So satellite station is also in ALTTC. but due to confidential government project, we are not disclosing about Inmarsat, and we are providing mobile satellite phones to BSF, Chhattisgarh Police, Navy, Central Secretariats, our army personnel from Inmarsat. So nowadays, satellite phones can also provide uh, data and video calls also. In 2018, it was only for voice, and cost of satellite phone call rate was only 75 rupees per minute. So this is cheaper, and global franchisee in Inmarsat is our franchisee, which is uh, used in India and across the world. And call may be connected in everywhere in the world from this site. So next slide is for cellular concept handoff strategy. So what is the meaning of handoff? If you are moving from one place to another place, so signal strength may get deteriorate from particular place to other place. So what should be done? There is some another BTS which is located nearby. So if signal of strength of one BTS is uh, deteriorating, then signal strength of other BTS may be more at that particular place. But there is some specific criteria that before getting down strength of the signal, user or mobile station should be hand over to other BTS. Otherwise, call may be dropped. So this is called handoff process, which is which is called minimum detectable signal, where that can be used to maintain the call. It is also below the threshold level. But if we cross threshold level, then it may happen that call will be dropped. So while moving from one BTS to another BTS, call should be successfully hand over to another BTS. Otherwise, call will be dropped. So this process is called handoff process, transferring. But how mobile station uh, measure the power? So there are some BCCH, broadcast channel, which is stored in SIM or SIM of the particular user. So mobile station periodically measures the power time by time. Uh, if and stores the 6 BCCH, strongest BCCH signals, that is which are coming from mobile BTS to mobile station. So it stores 6 BCCH. If one BCCH goes down, its strength is not detectable, or some other BCCH is strong, then it restores that BCCH which is strong from nearby BTS. Hence, it can transfer call from one BTS to another because it has always 6 strongest BCCH. So if 3 BCCH of BTS 1 is deteriorating the power, its power is not detectable or some other problem, then it stores the signal of BCCH of nearby BT. So this is the handoff process. Next slide, please. Move. Hello. Next slide, please.
Anandita, yeah, Anandita, change the slide.
So this is the handoff process, which is from one first case is improper handover and second case is proper handover. In case of improper handover, call is not given to another BTS and hand of threshold, level of handoff threshold is crossed, and it is also crossed minimum acceptable signal to maintain the call. But in second case, handover is proper. So call is transferred to other BTS before it crossed the threshold level. So this is proper handover. And during proper handover, the call signal power is immediately increased after handover. Hello, ma'am, please change the slide.
Yes. Okay, sir.
There are different types of access methodology: frequency multiplex, time multiplex, and code multiplex. There are three different access: frequency, time, and code. If multiplexing is done on frequency basis, frequency sharing basis, but time domain is continuous, then it is called frequency multiplex. So advantage of frequency multiplex is that there is no dynamic coordination is required, and it works for analog signals, while time multiplexing works for uh, better for digital, and synchronization is needed. While here the disadvantage of frequency multiplex is that the wastage of bandwidth, that is at all the time same frequency is used, so it is inflexible and here we have to use guard spacing. So this is the wastage of bandwidth. Ma'am, change the slide. In case of time multiplex, only one carrier is used. Only one carrier in the medium can be used at any time. So throughput is high for many users, and disadvantage that synchronization is required. So most of the hardware is used for synchronization purpose, for 30 to 40%. So this is the simple disadvantage. While advantage is that you can use different frequencies at same time, and sharing is on time sharing time sharing basis. So you can use different frequencies at a particular time slot. So it is useful and used for digital schemes. Next slide, ma'am. While in case of GSM, for better protection against tapping, boxes are used which are both on frequency multiplexing, which are multiplexed by frequency as well as time also. While in code division multiplexing, all the codes are used, all the frequencies are used at the same time, and so in case of code multiplex, there is spread spectrum technology used. All frequencies are used at all times. Ma'am, next slide. I think it will be for code multiplex. Okay. GSM. So this is the simple GSM spectrum, which is from 89 to 915 megahertz. There are 124 channels, 0 to 124. So 0 is not used and 124th channel is also not used, because until it is communicated to other operators or other agencies, which is just behind 124 frequency band or 0 frequency band. So 890 megahertz and 91 megahertz. So total bandwidth is 25 megahertz for uplink and 25 megahertz for downlink from 935 to 960 megahertz. So there are two frequency bands. Why these are different frequency bands? To avoid any interference and avoiding ring around, or for in case of uplink opposite to satellite, uplink frequency is lower. In satellite, uplink frequency is higher. In mobile communication, it is lower. So 890 to 915, 25 megahertz for uplink and 25 megahertz for downlink from 935 to 960 megahertz. This is for GSM. And each channel is up 200 kilohertz. 180 kilohertz of content and 20 kilohertz for guard spacing. And this may support up to 8 stations, assigning slot for transmission on demand. So 8 station, if we are using 3 frequency orientation is 3 frequencies in each, then 24 persons may be served at a time. Ma'am, next slide, please. Next slide. This is CDMA, code division multiplication. Hello. So there are several advantage and disadvantage. That advantage that bandwidth efficient and there is no coordination or synchronization is required, and it provides protection against interference as well as tapping. A disadvantage is lower data rates are there. Complexity is big problem here, and implementation using spread spectrum technology that can be used. Ma'am, please next slide. Hello. And another is signal processing in GSM. So this is, ma'am, another topic. So I think we should stop here, and because I have to go for another lecture in LTTC. So I think you can manage. Hello.
Okay, okay. Yes, sir. Yes, sir. Thank you
Because
so much, sir, for your very
Certainly.
informative talk. It's really very informative for all our participants. And
So,
thank you for your precious time.
another lecture may be scheduled at evening and at any time or any day.
Okay, sure, sir. We will let you know. Okay.
Thank
Thank
you,
you so
ma'am.
much, sir. Thank you so much, sir.
Thank you, Abhishek sir. So from audience, is any kind of query, questions? So I think in a chat box, I think one student, she has asked the question, sir, is there anything by which we can use a calling or internet option in an aeroplane? Hello. So I think Abhishek sir has left the meeting. Yeah, he's not there. Okay. So yes.
Ma'am, sir already answered the question.
Okay, he has already answered. Yeah, in between, yeah, I think he has already answered. Okay. So FDP, please FDP people, today our day 2 session 2 has been basically concluded. Okay. So rest of the VSC people, students, specifically Sharda University students who have been registered for the VSC course, please continue here. We are starting in a 2 or 3 minutes. Okay. And the FDP candidate, please leave the meeting. And please join tomorrow sharp at 10 a.m. for the day 3 session 1. Please join sharp at 10 a.m. tomorrow for the day 3 session 1. Okay. So FDP people, please, you may leave the meeting.
Okay, ma'am.
FDP students only, FDP candidates only. Okay. And Sharda students, VSC candidate, please continue here.
Okay, ma'am.
Okay.
Now for the value-added courses, I shall invite Dr. Usha Tiwari for giving an expert talk on MATLAB programming. Over to Usha Tiwari, ma'am.
Thank you, ma'am. Okay. Good afternoon, students, again. Okay. So today I will cover the MATLAB programming basics. So I know that it may happen that few students already are aware. So they basically can revise those concepts. Okay. And few students are new to the MATLAB programming. Okay. So I will discuss the basics of MATLAB programming. How do you basically, you have to proceed step by step. So those students who are basically aware, don't worry. It will be a revision for you people, and those students who are new to this language, you can basically, yeah, Umesh, good afternoon. Okay. So I'm sharing my screen. Just wait. So before starting this session, I just want to say what is the, I think you people are basically, few students are the second year students, third year students, and even final year students are all there. Okay, so I hope you basically know the C language. Everyone knows the C language. Okay, so what is the concept of a variables? What is the concept of loops? Okay, so I hope you people have studied in first year the C language, the Python. Okay, so as have anybody heard of the MATLAB? I think many knows. So MATLAB is basically it's a basically acronym we are using for the matrix laboratory. So MATLAB, it stands for matrix laboratory. Okay, just wait. My screen is visible. Okay, my screen is visible. So if I talk about the generally, it's not like that. The MATLAB language is basically MATLAB programming we people are using only for the electronics people. Okay, so MATLAB generally in every domain we people are using MATLAB. Even the computer science students are also using the mechanical, the other engineering students, they are also using the MATLAB. What is good about the MATLAB that we are having, for example, I want to use it in the field of image processing, okay? And you want to use in a field of a machine learning. And if I talk about some electronics area, for example, you are basically interested in using in your signal processing area or in your control system area. So we are having some specific toolboxes for a particular domain, okay? So what is the meaning of those toolboxes? Toolboxes means, for example, you are interested to use for the machine learning. So we are having only those instruction and only those set of operations which are specific for the machine learning. If I'm talking about the electronics domain, so if you are interested in signal processing or the image processing, so we are having only those tools in those toolboxes which are specifically for the image processing. Okay, so it's not like that. It's a domain specific language. But before starting or before basically going to the advanced toolboxes or something, you should basically know what exactly a MATLAB and how the MATLAB is working. Is my voice is clear, everyone? Participants, please. It's not
Yes,
like
ma'am.
that listening. Okay.
Yes, ma'am.
So small sort of a programming basically sort I will give. Okay, those students who are new to MATLAB, you can basically, you know that MATLAB, they are providing a online portal. Okay, for example, nowadays, if you are not coming to the campus, you can use that MATLAB online. Just you can register there in a MATLAB online by using your college email ID, because they are giving the access of 1 month or 1.5 month free access to the college students. Okay, so you can basically register yourself on your MATLAB online portal. Okay, and after that you can use all the basically the MATLAB programming tools in their online portal. Okay. So next, introduction. So generally the MATLAB, it's a program for doing the numerical computation. It's not like that the nowadays we are only doing the numerical computation, but when we have basically started the MATLAB, Okay, so at that time, nowadays, the current version MATLAB 2020 is basically available. Okay, so it has been, I think, started in 2003 or 2004. Okay, so in the starting time, we are basically doing some numerical computation. Okay, and if I talk about its origin, so it's originally designed for solving the linear algebra type of a problem. But day by day, as the technology is progressing, so nowadays we are doing every sort of, you can say that every kind of a phenomena we are, in every domain we are using the MATLAB. Okay, so if I talk about the name of a MATLAB, so the name MATLAB is basically derived from the matrix laboratory. Okay, so it's, you can see that the acronym MATLAB, so 3 words are taken from the matrix, the MAT, mat. Okay, and the 3 starting words are taken from the laboratory. Okay, so why it is called as the matrix laboratory? Because whatever the instructions, whatever the inputs or whatever the variables or some constants, whatever the things that we are entering as a variable name or something, so all those things, the input that we are giving, it is in the form of a matrices. Okay, so whatever the input that we are supplying is basically in the form of a matrices. So that's why this language, it is called as the matrix laboratory, or in short, named as a MATLAB. Okay. So MATLAB has since been expanded and now has been built-in function for solving the problem requiring. So starting we are using for the algebraic operations, but nowadays we are using for the data analysis, we are using for the signal processing, for the optimization, and many other areas, your machine learning, your deep learning, your neural network. Okay, so your biodomains. Okay, so in every field nowadays we are having some specific toolboxes for the particular kind of area. So we are using MATLAB for that. Okay, so it also contains some functions for the, it's not like that only the computations and the data analysis sort of things we are doing. It also contains some function for the 2D and 3D graphics. Okay, so we can also visualize by using the graphics. Either we can use the graphics in a your 2-dimensional, and similarly we are having also a 3D graphics also. Okay, so for example, as you open the basically you are opening the, just wait, I'm zooming it. For example, as you open your MATLAB, okay, so you will get the 3 type of a windows. Okay, how many windows? 3 type of a main windows, but apart from these 3 windows, we are having the other windows also. Okay, so first is called as the command window. Which window? Command window. Okay, in a command window, there is a prompt operator. I will show this in zooming. Okay, so in a command window, it's a prompt operator. So what is the use of command window? Command window means that, for example, you want to, whatever the output, for example, you know that in a C also you are saving the program, after that you are running the program. So after running the program, you are getting the results in some window. Similarly, in case of a MATLAB, after running the program, we are getting the output in a command window. Okay, and what is the second use of this command window? Command window, for example, you don't want to write a big program and you want just a result, single instruction. For example, you want to do A plus B or a 7 plus 9 and you want the answer. Okay, or 7 square plus 19 square, and you want the answer at the same time, and you are not basically interested in writing a long programs. So at that time, it's basically the command window give you the result at the same time. Just you type here 4 plus 9 and just put the enter, you will get the result. Okay, next we have the workspace. In a workspace window, for example, recently, whatever the basically the folders or the files that you have opened, that workspace window will show all these. Okay, next is the command history. Command history basically show the what are the different type of a variable that you people have used in a past. Okay, while you are doing the programming, so command history will show the basically the what are the different variable that you have used, and similarly workspace will show the folders and files whatever the you have opened recently or what you are using. Just wait. So if I talk about the MATLAB environment, so MATLAB environment is basically command oriented, just like a Unix. Okay, as the Unix environment is the command oriented Unix language, So similarly, the MATLAB environment is also a command oriented. A prompt appear on the screen. Okay, a prompt will appear. I will show you what is we are calling it as a prompt. So this sign is basically we are calling as a prompt. This sign we are calling it as a prompt. Okay, so what happened? A prompt appear on the screen and a MATLAB statement can be entered. So whatever the kind of instruction you want to execute, so on that particular prompt link, you can put that instruction. Okay, so when after just giving the command, you just as you enter you push basically the enter key. After that particular statement, whatever the statement that you have given near to the prompt, so that statement will be executed. Okay, so now there is a good concept of a semicolon here. Okay, as you people have used semicolon, anybody can tell me what is the role of a semicolon in C language? Anyone?
End of statement.
End of the statement. Okay, so but if I talk about the semicolon here, for example, I have written a 10-line program. Okay, and I want that that in my command window, as I said, the command window will show the result, the end result. For example, I want that I want the result of a third statement, then fifth statement, then the last statement. Okay, so if I basically put a semicolon, okay, so for that particular statement, the program will run. Obviously, the program will run, but the no result will be displayed. Okay, so where you don't put the semicolon, that for that particular instruction, result will be appear in a prompt. Okay, so here, yeah, we are using a semicolon for basically ending the statement. But here, in case of a MATLAB, for example, we are entering the semicolon in particular programming statement. So for that particular statement, the result will not be displayed in the command window. Okay, and for example, we are not putting the semicolon, it means that the result will be appeared in the command window. Okay, so it is a use of semicolon in a MATLAB. As I discussed previously, we are having a 3 type of a windows, not only 3, but these 3 are the main windows. Okay, so command window, we can type the commands. Okay, and just by pushing the enter, we can get the result at the same time on the command window. So in a workspace, you can view the program variables. For example, what are the program? For example, in my program, I'm using the 5 variables. So what are those variables? And even the size of those variable you can check in a workspace. For example, you want to clear the workspace every time you are running the program. Okay, and it may happen that in a workspace, many variables are there. So you can clear those workspace variable by putting the command clear. Okay, so now double click on that variable to see the array editor. For example, you want to know more about the size of that particular variable. So you can double click at that particular variable. Next is the command history. As I said, the history window. So in a history window, command history, for example, once I use the addition command, after that I use the multiplication command, then then some division sort of or back division. So all those, whatever the commands that you people have used in recent times, those commands you can check in a command history. Okay, and save a whole session using the diary. For example, you want that in a 1 hour duration, you have done some sort of a programming, so few programs, 2 or 3 programs, and all those programs, if you have some set of past commands and you want to save the whole session, then you can save those commands, whatever the commands that are used in recent times. Okay, so just see, as you are opening the MATLAB, you can see it's a command window. Okay, so here the prompt will appear. Okay, so this is the current directory. So current directory is basically, here is an example is shown. For example, I'm using the bandpass format, one folder it is showing, then the boundary refined, then the convex all. So these are the some current folders that you people have opened in the MATLAB. Next, here we are having two options, current directory and workspace. So you can click onto the current directory and also you can click onto the workspace. The workspace will show the variable and their size, array size. Next, it is a command history. You can see that, for example, in your program, you are using the plot instruction, you are using the plot again plot, figure. So whatever the commands that you people are using here in your command window or your editor window, so all those commands will be visible in your command history. Okay. Next, few other, apart from these three windows, few other windows are also there. For example, you have plotted one plot after running the program, 5 or 6 instruction, you have plotted a plot. Okay. So one different figure window will basically pop out. Okay. Figure window will pop out only in case when you are having some sort of a plots in your program. Otherwise, there is no figure window. So figure window will be pop out only when you are having some graphic commands. Okay. Next is the help window. Okay. So help window, it's very good feature in case of a MATLAB. As you open the MATLAB software, you are having some help section. Okay. For example, you don't know the MATLAB, you don't know anything. You can basically study the MATLAB from scratch by using this help window. Okay. So help window give you the guidelines from the starting, just from the basics. You can step by steps, you can basically study the basics from there. And after that, same by same, you can basically implement those basics on your, just wait, some chat messages. Okay. So you can implement those basics by parallelly, you can use those instruction on your command window. Okay. So next we are having a help window. As I said, it's very good. Help window, you can study everything from a scratch. You can move step by step. Next is the editor window. As I said, in a command window, you will give the command, you will get the result at the same time. Okay. But for example, hello. Okay, sorry for interruption. Some call is there. Okay. So next is editor window. For example, as I said, for example, you are typing something on your command window. Okay. And as you close your MATLAB, okay, so everything will be basically vanished or erased. Okay. And for example, you want to write a bigger program, you are writing some program and you want to save a program. And even after some time, you can check that same program. Okay. So in that case, we never write a program in a command window. Okay. We always write a program in editor window. Editor window, whatever the programs you are writing in an editor window, you can run those programs. And even in future, you can basically open the same file and you can run the program. But command window is not allowing these kind of a process. Command window, as you close the MATLAB, the command window will be closed, and whatever the things or whatever the sort of a process that you have done in a command window, all those things will be erased. Okay. So that's why generally while doing the programming, we are always writing our programs in an editor window. Okay. So that in future also we can access those programs. Next is the current directory window. So whatever the files are there in a current directory, so you can see as I have shown in this particular figure. Okay. So these are the current directory, whatever the file and folders are available. So it will show. Okay. Next is the launch, your launchpad window. Okay. To provide the access to tools, demos, and documentation. For example, in every MATLAB software, some demos are basically saved by the MATLAB people. Okay. And for example, you want to use specific tools and specific, you want to see some specific demos. Okay. And some documentation. So you can basically use the launchpad window. Okay. But again, I will say these three windows are the some main window, and these other windows, it's basically application specific, whether you want to use it or not. Next is the command window. So how to use the command window? Again, I'm repeating, in a command window, this prompt, we are calling it as a prompt. Okay, so this prompt will always appear in a command window. What you have to do, you have to basically type your code. Anything you want to basically do. Okay, and not a single line code. You can type a multiple codes. Okay, and after that, you have to press the enter. Okay. So as you enter, your command will be executed, and whatever the output you have basically according to the code, whatever the output you are expecting, so that output will be displayed in the command window. Okay. So another thing, semicolon. Again, I'm repeating, if you put the semicolon, the output will not be displayed. Okay. And if you don't put the semicolon, the output for that particular instruction will be displayed. Okay. For example, you are writing very long instruction. Okay. Just see my window. For example, I'm writing if a command is too long and long, and it is going to the next line. Okay. For example, you are writing too long command and it is not basically fitting to the single line. So in that case, you have to provide the ellipse. Ellipse means you can basically provide the 3 dots here. Similarly, 3 dots you can provide you can basically use the 3 dots in a next line and you can continue your instruction. Okay. So whenever your instruction is too long, in that case, we are using the ellipse. Okay. Next, command can continue line after the line up to 4096 character. But there is a limitation. It's not like that. You are writing some so long command. Okay. So only limitation is there. Limitation is there that you can use only 4096 characters. Okay. Any confusion? So this is the MATLAB command window. I already described. Launchpad, okay, and the command history. Next, the few things. The MATLAB is case sensitive, okay? So it's not like that you can use same time the uppercase. If you are defining the capital A, similarly, if you are defining another variable small a, so both are basically different, okay? So MATLAB is case sensitive. For example, I have written one instruction A plus B, okay? And the third person who is reading the program, he don't know what exactly a plus B. Or it's a simple example, A plus B, everyone knows. But for example, you are basically typing some command and you want to give some comment. Many times we people generally, you can search on the online also, whatever the MATLAB programs are available. So generally they are putting this percentage symbol. Okay. So this symbol is for, as you provide this symbol in a program, the color changes to green. Okay. The color changes to green and you can write your command, explanatory comment that this command is meant for addition. So this command is meant for subtraction. This command is for multiplication. Okay. So whenever in a program, apart from your command, you want to write the comment, in that case, we have to use this percentage symbol. Next is the CLC. Generally, we are using this instruction to clear the screen so that every time you are running the program, your command window will be cleared. Again, if you want to recall the previous type commands, you have to use the up arrow. Similarly, if you want to go to the next command, then you have to use the down arrow. Okay. Next, some common arithmetic operations are there, okay, in case of a MATLAB. So for addition, simply we are using the plus sign. For subtraction, we are using the negative, okay. And for multiplication, we are not using the cross symbol, we are using the asterisk symbol, okay. We are using the asterisk symbol. Similarly, it's a right division, okay. So that simple division, we are calling it as a right division, okay, 5 by 3. It's a left division, means 5 by 3, it is equals to reverse of it, 3 by 5. And next, for example, you want to raise the power, we are using this cap operator, okay. We are using this cap operator. For example, you want to write 5 cap 3, so 5 raised to power 3, it is 125. So these are the some operators. Just see the, as I have discussed the basic variable, just see the simple program. Okay. Just see the simple program by MATLAB. So this is the percentage symbol. So percentage symbol means that we are writing some comment. Okay, it is not a command. It is just a comment. So why we are writing comment? Anyone? Why we are writing comment? So that any third person who is not used to of MATLAB can understand what exactly you are going to do. It's just like a comment for the third person who don't know anything about the program. Okay. So here we are writing to get started, type one of these commands. So you people, I will share my PPT also. Okay. For example, you don't know anything XYZ about the MATLAB. So you can start from the scratch. Okay. So just for example, you are typing in a command prompt, you are typing A equals to B semicolon. And next you are typing B equals to A by 2. Okay. So it means just see the difference of semicolon. So as I have basically entered after this statement, I'm getting the result B is equals to 2.5. Okay. So is it clear? For example, I'm not putting the semicolon here. So what the answer we will get? We'll get A equals to 5 and B equals to 2.5. Okay. Just see the use of semicolon. As I put the semicolon here, so in an answer window, this statement or this command or the answer of this command is not visible. Okay. But here I have not used the semicolon. It means answer of this particular command is visible. Okay. Next, same way as we are doing in a mathematics, here also we are having some order of precedence. You know the BODMAS. You know the BODMAS in mathematics. Okay. So same way, first how, for example, some algebraic expression is there. So how to solve that algebraic expression? So we are using parenthesis. First we are solving the parenthesis. Then we are solving the exponentiation. Okay. Then we are basically doing the multiplication and division. Then we are doing at last we are doing the addition and subtraction. So it is some sort of a order of precedence, same way as we are using a BODMAS in normal mathematics. Okay. So some formats are there, display formats. You know that, for example, you are getting the result 2.1923 something, some long decimal points. Okay. So for example, you don't want to show that long results and you want to show only the 2.190. Okay. So there are some sort of a formats are there. Okay. And you can change those format. Okay. But by default, MATLAB shows after decimal, it will show the 4 decimal digits. Okay. So by default, it is using the short format. And if you want to see the long, then you can basically type long in front of that particular variable. Okay. Just see that format short fixed point with 4 decimal digit. For example, I'm using the short format, which is by default short format. So we will get the fixed point with 4 decimal digits. Similarly, the format long fixed point with 14 decimal digits. Okay. So you will get the result up to 14 decimal digits. Then format bank. Okay. So in a format bank, we are only using 2 decimal digits, means we will get the answer as 2.19. Then format compact, eliminate the empty lines. If some empty lines are there, so those empty lines will be eliminated from the answer. Format loose adds the empty line. Okay. For example, in between the two results, you want to add some empty line or some blank spaces. So in that case, the format loose will basically add those blank spaces and format compact will basically eliminate those empty lines. Okay. Now we are having some elementary mathematical functions. Okay. In MATLAB also. So SQRT, for example, you want to find out the square root of X. So we'll use the SQRT operation or SQRT function. Okay. So SQRT, it stands for square root of a variable X. Similarly, for exponential, we are using the EXP. Okay. So it stands for e raised to power X. For example, you want to find the absolute value of a particular operator. So you can use the ABS. Just wait. Okay, students, continue. So next, for example, if you want to use the logarithmic operator, natural log, you know that for a log, we are having a base E log and similarly the base 10 log. Okay, so we are having the some different instructions for both. So log x is for the natural log and log 10. Okay, log 10, you have to write log 10. So log 10 is for the base 10 log. Okay, next we are having a factorial. For you know that what is factorial? Factorial 5 stands for 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay. If you want to find the factorial of a 5, so you can use a direct instruction factorial. Okay. Next, apart from the elementary instruction, we are also having some trigonometric function. Okay, you know that there is a use of a trigonometric function also. So direct, we are having direct trigonometric function, sin x, cos x, tan x, and cot x. Okay. Next, we are having some round off operations. Okay. For example, you are getting some long answers and you want to rounding. You want basically some rounding functions. Okay. So first that we can use a round x. Okay. So the round x basically round to the nearest integer. Okay. For example, you are having an answer 2.7. So obviously it will round off to 3. Okay. If we are having 2.4, so it will round off to 2. Okay. Next, we are having the fix x. So rounds towards the 0. Next, we are having an instruction seal x. So rounds towards the infinity. Rounds towards the 0 means it always round off towards the lower value. Round off towards infinity means it always round off to the higher value. For example, you are having 2.6. Okay, so it will not do it like 2.6 means that it will fix toward the 2. And if you are using for 2.6 the seal function, it will always, for example, you are using for 2.4 the seal function, it will do the 3. It always round toward the infinity means to higher value. It always round toward the lower value. Okay. Next, we are having a floor function. It round towards the minus infinity to the negative digits. Next is the remainder. Okay. For example, you want to find the remainder, whatever the remainder while we are getting by dividing the two functions x and y. Okay. So the remainder will return the remainder after x is divided by the y. Next, we are having the signum function. I think in many places we require a signum function, that sin x by x. Okay, so we can use the signum function. Elementary function. As I said, it's a very good option in case of a MATLAB, a help window. For example, you don't know XYZ and you want a use of a help window. Simply you can type a help L function. So you can get details of all the elementary functions which are available in MATLAB. Simply you can go to the command window, type, don't use this word type help elementary function. Okay. Next, similarly, apart from the elementary function, we are having some advanced functions also. As you people have studied in your first year mathematics, some Bessel function, beta function, and gamma function. And you want to basically know in detail what are those your special functions. So you can type in a help spec functions. Okay. Similarly, help your so apart from your elementary function, if you want to basically study some special functions, so you can use the help window. Okay. So next is basically your how we are defining the variables and how we are basically using the operators in MATLAB. Up to this point, it is clear. Any confusion? Anyone, please? And it's my suggestion to everyone, please try to do all these small operations. Okay. Anyone, any confusion?
No, it's good.
Okay. So now how to, you know that many times we require how to basically define when CUNY is asking, we need to declare the variables. Yeah. When CUNY, we are basically discussing how to declare the variables. Okay. So now For example, how to define the scalar variables. Okay, you know what is a scalar quantity? Anybody, what is scalar quantity? What is?
Ma'am, the quantity which have only magnitude is known as the scalar quantity, like distance, and the quantity which have both magnitude and direction.
Then it is a vector quantity. Okay, if the quantity is having only the magnitude, then we are calling it as a good Rishabh. Then we are calling it as a scalar. Okay, and it when it is having a magnitude and also a direction. Okay, the angular or a theta angle that we are defining. So then it is a vector quantity. Okay, so how to define a scalar variable, a constant quantity here in a MATLAB. So what we are doing, the variable is name made of the letter. So how to name a variable? Basically, you can name a variable by using a letter or a combination of a several letter. For example, you can define a variable as a or some ABC as a variable. Okay. After that, after defining a variable by using some letter or the combination of several letter, you can assign a particular numerical value to it. Okay. So actually the name of a memory location, if I say that a name of variable, it means that you are assigning some memory location, and that memory location name, for example, I'm giving A. Okay, so it means that I am assigning A is equal to 15. For example, you are writing A is equal to 15. It means there is a memory location whose name is A, and I am assigning to that particular memory location, the value I am assigning is basically 15. Okay. So variable name means that actually the name of a memory location, and assignment operator. So generally we are using equal as a assignment operator. Okay. So now it's a, you can say that it's a kind of a, how we are doing it. On the left side, we are writing the variable name. Okay. And equal to is basically the assignment operator. And then we have to write a numerical value. Either you can write an exact numerical value, or you can write a some kind of a computable expression. Okay. So both the things we can do. Just see the examples. For example, x is equals to 15. Okay. And next we are writing x is equals to 3 multiplied by x minus 12. So it is an example of expression. Here to a variable we have assigned one expression. And this is an example that here we have assigned some constant value. Okay. So this is a way how we are basically defining the variable. For example, when new variable is created in a MATLAB, so what MATLAB does? For example, you are writing x equals to 15. So what MATLAB does? So MATLAB basically assign a appropriate memory location. Okay, and where assigned value can be stored. For example, you are defining x equals to 15. It means MATLAB has assigned a memory location, and to that particular memory location, MATLAB has given the name as x. Okay, and the value assigned, the 15, is basically saved in that particular memory location. Okay, is it clear? So when variable is used, for example, whenever you have defined x equals to 15. So, and in the after 2 or 3 commands, you are calling that value x. Okay. So what the MATLAB will do? MATLAB basically will go to that particular memory location and fetch the data, whatever the data is stored in that particular memory location. Okay. So if assigned new value content of memory is replaced, just see an example. For example, I'm assigning a variable ABB, the value is 72. Okay. And at the same time, in the next instruction, I change the value ABB equals to 9. Okay. So when ABB is equals to 72 and then ABB equals to 9. For example, you are typing ABB. So the value of ABB you will get as 9, not 72. Okay. Whenever to the same variable name you are assigning the new results, so the old stored data will be replaced by the new value. Okay. The whatever the old stored data is there, it will be replaced by a new value. Okay. So keep in mind, whenever we are assigning a new value to the memory location, so that new old data will be replaced by the new value. Okay. Next, we are having some rules, you know, that in the C language or in any of the language, generally we are having some rules that how can we name a variable, okay? So as I said, the variable names are case sensitive, okay? If you are using a small a and if you are using a capital A, so both two, they are basically acting like a two variable, not a one variable. Small a is a different variable and similarly the capital A is the different variable. Next is the variable name can contain up to, yeah. Anyone is asking something? Similarly, there is a limitation that you can use the variable name can up to 63 characters. Okay. So there is a limitation. You can use only 63 character. It's not like that beyond 63 character. Even the 63 characters are not required. Okay. So next, the variable name must start with a letter. It's a compulsion that it will always start with a letter followed. It's not like that you are writing, first you are using the digits or first you are using the underscore. No, you can't do this. Okay. Always it will start with a letter and after that you can basically follow it by either by a letter or you can use a digits or you can use a underscore means some special symbol you can use. Okay. But condition is that it must begin with a letter. Okay. And avoid using names of a built-in function for a variable. As I said, many operations are there which are already built in MATLAB. Okay, you can directly use those built-in functions. So don't try to avoid giving the name of your variable same as the built-in function. Okay, if you do, so you will get some kind of an error in your program. So there are some predefined variable, as I said, the built-in variables. So ANS, it is the variable which I are using to get the answer of the particular last operation. Okay. So EPS is basically the smallest difference between the two numbers. Okay. And I, you know that the iota symbol generally we are using in a complex variable. Okay. So I stands for under root -1. Okay. Similarly, you can use for the iota symbol, you can use the I also, you can use the J also. Okay. So same way it will for I and J, it will use the value as under root -1. Next, we are having the inf. Inf stands for your infinity. NaN means that it's not a number. And similarly, for example, in your operation, you are basically interested in using the pi symbol. So simply you can use the word pi. Okay, automatically it will use the value 3.14 or in angles 180 degree. Okay. So there are some other useful MATLAB commands who list the known variables. If, for example, you are using the who, so whatever the known variables that currently you are using, you will get those known variables whose list known variable plus their size. Okay. So known variable and their size will also be displayed. As I said, help is a very good command here. Okay. So you can, for example, you don't know, so you can type a help XYZ. Okay. For example, you want to know help SQRT. What SQRT is doing? You can basically type in a prompt, command window prompt. Clear is basically clear all the variables from the workspace. For example, your workspace is overloaded and you want to clear that workspace. So we are using 3 clear instruction. CLEAR, generally it clears the workspace. Okay. Clear XY. For example, in a workspace, you want to clear only specific variable and you want to keep the rest of the variable. So you can use specific clear XY. So it will clear only X and Y variable from the workspace and rest of the variable will be remain as it is. And next is the CLC. So see the difference between the two clear command. Clear, CLEAR, clear is basically clearing the workspace and CLC is for clearing the command window. As we are doing many operations in a command window, your command window will be basically the occupied, okay, or it is filled, okay. And if you want to clear, you can simply use the command CLC. Next is the array. As I said, it's a MATLAB. Okay, MATLAB it stands for your matrix operations. So obviously we are supplying the data in the form of arrays. Okay. So array is basically the list of number arranged. So what is the definition of array? How we are arranging the numbers in a row and columns. Okay. But in case of a MATLAB, we can use the two type of a array. Simplest array. Simplest array means your one-dimensional array. Okay. So generally one-dimensional array means you are using only row matrix. You are using only row matrix. Okay. Similarly, for example, you are using the complex array. Complex array means your 2D array. 2D array means it is having not only the row matrix, you are having the rows also, you are having the column also. For example, your 4 by 4 or your 6 by 6 or your 8 by 8 matrix. Okay. Next, now comes how to create a vector, how to basically variable, how you are, as we are defining the simple variable, similarly, how to define the arrays in case of a MATLAB. Okay. So what we are doing, creating a vectors from the known list of a number. Okay. So for example, you are creating some variable. So how we are defining the array? We are putting this square bracket. Yes, anyone? What we are using for defining the arrays or even the single constant in a MATLAB, we are defining by using these square brackets. Okay. So in these square brackets, we are writing the vector element. Okay. So how, for example, I want to basically write a 1 by 4 means one row and 4 elements. Okay. So how to separate those elements? How should I write? I will write, for example, you want to write 1, 2, 3, 4 in a single row. So how will write? I write 1 space 2 space 3 space 4. Okay. So how to basically separate elements? Basically, we have to give a space, or you can also use a comma. But generally, we people are using the space. Okay. Is it okay? Next is the column vector. Okay. How to define a column vector? Generally, you know that in a column, to separate first column, then second column. What we are doing, we are always using a semicolon symbol. I'm giving you the example also, don't worry. We are using a semicolon symbol. Just see. So for example, you want to write a row vector, we will just provide the space. And if you are writing the column vector, so for separating a one column to the second column, we are using a semicolon operator. Okay. Now, for example, you want to create a vector with constant spacing. Okay. How to get a constant spacing in a vector? Okay. Just see an example. You want to write first number as a 1 and the last number as 10. Okay. And you want to give a constant spacing of 2. Okay. How? So what the output you will get? 1 space 3 space 5 space 7 space 10 and so on. Okay. So whenever you want to give a constant spacing, for example, you want to display the 10 elements which are lying between 1 to 100. So simply you can write 1:10:100. Okay. So in between the starting value and the last value, so the first letter basically it shows the first term, and the middle one basically shows the what kind of a spacing that you are providing, and the last term basically it is the last. So in my example, 1 to 100, the first term will be 1, the last term will be 100, and Q will be specifically 10. Okay. Are you getting, everyone? So similarly, either you can provide a square bracket here, or you can also write like this, M:Q:(N), or you can write 1:10:100. Okay. So it will display all the numbers which are lying between 1 and 100 by giving a spacing of 10. Okay. Next is, we can also use a particular command. With that command is the linspace. Okay. So in a linspace, linspace, you need not to provide the middle term. Okay, what we are doing, for example, I am writing linspace initial value, final value, and number of elements. For example, you have written here as a 1 and final value as 100, and you wanted 10 elements. So automatically the linspace instruction will divide this particular range 1 to 100 into the 10 elements. Okay, into the 10 elements. So it is a direct instruction which is called as the linspace, which will provide a, according to the number of elements, it will provide the appropriate spacing between the first element and the last element. Is it okay?
Yes.
Or everyone is sleeping?
No, ma'am.
So try to, if you are having some sort of confusion, you can also ask question. Okay. So this is that we are giving basically to create a row matrix. Similarly, for example, you want to create a 2D matrix, two-dimensional array. Okay. So in a two-dimensional array, as I said, to separate first row. For example, you are writing in a first row 1, 2, 3. Okay. And second row is 4, 5, 6. So I separate it by using the semicolon. I use it the semicolon. So I will write, so my MATLAB will understand only when I put the semicolon. So I write it here 1 space 2 space 3, then put the semicolon. Semicolon means I am going to the next row. So next row I will write 3 space 4 space 5. Okay. Similarly, again I will put a semicolon. Then I will write 6 space 7 space 8. Mike. Okay. So next is all the row must have the same number of elements. Okay. Otherwise we are not able in a position to create a matrix. You know that the number of elements in every row are same in case of a matrix. Next is there are some direct instructions in a MATLAB to create a zeros matrix. For example, you want to create a 3x4 zero matrix. In many operations, zero matrix is required. So you can create a m by n matrix of 0 by using the direct instruction zeros m comma n. You can write zeros 3 comma 4. Okay, so you will get a 3x4 matrix in which all the elements are basically 0. Okay, so next we are having a transpose operator. You know that in a matrices we are using the transpose operator. So for example, you have defined it looks that someone is basically doing some breathing kind of activity on the mic. Please stop this. Okay. So next is your transpose. So same way here we are using the transpose operator. This is as a transpose operator. Just see a sample program example. For example, I have defined one matrix as 3 space 8 space as 1. So it's generally a row matrix. So we'll get the answer as 3 space 8 space 1. And you are basically using another variable BB, and BB is basically nothing. It is a transpose of AA. Okay. So that's why the BB is equals to 381. So you will get it's a row matrix. So by basically doing the transpose, it is converted into the colon matrix. So it's not like that this operator is only used for the row matrix. You can use it for the square matrix also and for the other order matrix also. Next is many times you want to address a particular element. Okay. So for that we are using the array addressing. Okay. For named as VE. For example, my matrix is VE and I want to address basically the fourth element. Just see the example, the previous one. So either you can, for example, I want to address 8. So what should I write? I write AA in bracket 2. So because its position is, just wait, its position is 2 or 0. Okay. So because this is the first variable is 3, you can address is just by typing AA1. Similarly, you can address the 8 by typing AA2, and you can address the 1 by typing AA3. For example, you are having the square matrix. So square matrix, you can address the element by typing, for example, in a third row, you want to address the fourth element. So simply you can write 3, 4. 3, 4 means in a matrix, you have to go to the third row, and in a third row, you have to address the fourth element. Okay. Just wait, some chat message. Very good. Okay. So next is the using a colon in addressing. Many times we are using the colon. For example, my matrix name is VA matrix. Okay. And you are just writing the colon, and you are not expressing the starting value, the initial value. So automatically all the elements, just see, for example, in this case, you are writing AA in bracket colon. Colon means it will access all the elements, 3, 8, 1, all the elements from starting to the end. Okay. Similarly, you are writing VAM, N. Okay. And you want to basically, in a 3 by 4 matrix, you just want to read the first row elements. Okay. And in a first row, you want to read from M value to the N value. So you can specify. Okay. Similarly, other colon operators are there. And for example, you want to fix the column and you want to read all the row elements. In this reverse, if you have fixed the row and you want to read all the column elements. Okay. And here, what we are doing, we are reading all the, basically in a column, we have applied the instruction M to N. Okay. Here we have applied the instruction M value to N value in a rows. Okay. So these are the some column operators. You can just by doing, taking an example, just see the example. Simple. For example, you didn't understood the previous, whatever the instructions I taught. So you can see the example. For example, I defined the variable df equals to 1, 2, 3, 4. Okay. So you will get df as 1, 2, 3, 4. Okay. And here you are basically writing df 5 to 10. Just see, it's very good operation. df 5 colon 10. Okay. So it means that in my previous variable, I don't have fifth row. Okay. I don't have the fifth row. So what it will do, for example, you don't have such a row. So, and you are basically using some instruction. So you are using df 5 to 10 means fifth row to 10th, fifth element to the 10th element. Assign these value on the right side. What are the value? 10 to 35 with the increment of 5. 10 to 35 with the incremental value of 5. So my new df will become 1, 2, 3, 4, and fifth element is 10. Sixth element is 5 increment 15. Sixth element is again 5 increment 20. Then another next element is 25, 30, and 35. Now you are having 10 elements in your matrix. Okay. Now I have defined another matrix. AD is equals to 5, 7, 2. Okay. So AD is equals to 5 space 7 space 2. And you want to address the 8th element. But here there is no 8th element in my matrix. Okay. So whenever we don't have that element, it means that we are assigning that value. Okay. So what this instruction will do, it will create 5, 7, 2, and 8th element is 4. So rest of the element will become automatically 0. First, second, third, fourth, fifth, sixth, seventh, and 8th element will be, the value assigned to 8th element is basically 4. So this operator basically behave in a two ways. You can even address by using this operator, and you can also assign the value by using this operator. Okay. Okay, so this operator will assign the values only in a case when that particular row element or a element is not existing in your existing matrix. Okay. Just see the next case. For example, you want to add the two type of matrices. Okay. For example, you are having two matrices are there. One is the RE 381 and another matrix is the GT. The value of GT is 4:3:16. Means 4, 7, then 10, then 13, then 16. Okay. So now we are basically using third variable KNH, and its third variable's value is RE space GT. It means you are adding basically two matrices. You are adding means not that addition operation, is just basically you are writing these two matrices side by side. Okay. So now the KNH is basically 381 and then GT is 4, 7, 10, 13 and 16. Okay. Now another example of adding elements to a matrix. So my matrix is 1, 2, 3, 4, colon 5, 6, 7, 8. It means this is the first row and this is the second row, because we are using a colon operator to differentiate a first row with the second. So we'll get E as 1, 2, 3, 4, 5, 6, 7, 8. Okay. And you are basically now again adding elements. In a third row, I am adding colon means all the elements in the ratio of 6:4:9. This is wrong because because if you are adding the 6 and 4, so just see what the answer you will get. 1, 2, 3, 4. It's the same. 5, 6, 7, 8. And the next is basically this 4 is written wrong. Here you have only 1 because the next row, third row, elements are 6, 1 increment 7, next increment 8, and next increment 9. So this is a simple mistake here. Okay. Either you can write simply 6:9 or you can write 6:1:9. Okay. So any confusion up to this point? I hope similarly we are having some more examples of deleting the elements. So I think the time will not allow me to basically to extend this more. Okay. So there is one more example. As in a previous slide, we are discussing how to add the elements. Similarly, in a existing, for example, in a matrices, if you want to delete the element, you can delete a particular element also by addressing its position. Okay. And if you want to delete a range of element, you can do the same thing also. Okay. So now I would like to take some questions from the students. Okay. And after that, my suggestion is that I will pass on these slides. You can try these sort of a basic programming, and even the 1 hour is not enough to cover all the even basics. Okay. So it's my suggestion. So I have initiated some introduction. You people basically can carry on, and MATLAB is basically, it's very important language as your branch is concerned. Okay. So again, I'm repeating the same sentence. It's not that the MATLAB you can apply in a single domain. And if you are a second year students, then in the third year also, in every subjects, in different subjects, you can use the same language. Okay. So by using some different sort of a control your toolboxes. Okay. So we are having a separate toolboxes for the separate domains. Okay. And if you are working on some domain specific, you can try those toolboxes which are basically useful for your particular domain. Okay. So students, any questions?
Is there any queries from the students?
No, ma'am.
Any queries? Second year students, specific or BSc?
No, ma'am.
people can basically go to the MATLAB online. You register yourself in the MATLAB online. Okay. So you can get basically, you can try the sort of a programming there. Okay.
Is there any queries from the students? Okay.
No, ma'am.
Thank you. Is it MATLAB a programming language? Hello, Usha ma'am.
Yeah, ma'am. Yeah, ma'am.
एक क्वेश्चन है कमेंट बॉक्स में, इज मैटलैब अ प्रोग्रामिंग लैंग्वेज?
Yes, yes, Rasmata, it's a programming language. Yeah. Yeah, it's a programming language you can use in various domains. Okay, being you are an electrical student, you can use it.
Implement this MATLAB in any of the applications too.
Yeah. Okay, so it's just a basics. Okay, you can go beyond that because, for example, in an application, as I discussed in the starting part, that it's not a MATLAB that only electronics or electrical people are using. You can even in a electrical or electronics, we are having some specific domains. For example, I'm talking about the controls, I'm talking about the signal processing, I'm talking about the image processing. Similarly, in a electrical, we are having the different areas. For those areas, we are having specific toolboxes. Okay. So after understanding the basics, you can go to those toolboxes which are application specific. Okay. Even the computer people are also using MATLAB. Okay. Any other query? When CUNY? Rasmata, okay, I answered when CUNY, if but it want to modify the value of a particular element in a row. I already basically discussed how to modify a particular value. Okay. You can address a particular value. Okay. You can change, you can assign a new value to a particular element. Okay.
Thank you, Usha ma'am, for giving such a basic knowledge of MATLAB to all the students. Thank you very much. It was a very valuable session for the students. I hope all the students have understood the basics of MATLAB, and we expect more projects by implementing the MATLAB. Am I right, students?
Yes, ma'am.
Yes. So, thank you so much, Usha ma'am. Thank you.
Thank you, ma'am. Thank you, ma'am. Yeah. Okay. So now we are basically, so tomorrow, please you join on time. Okay. So from again, tomorrow morning, 2 sessions and 2 sessions in the evening. Okay. Okay. Thank you so much.
See, all the students must join tomorrow at 10 a.m. Attendance will be taken only from the Zoom link. At any time, the attendance will be taken. So kindly all the students join on time.
Hello.